Welcome back to the Sleepy Scientist, a calm little refuge where the lights are soft, the pace is slow, and curiosity is allowed to stretch out and yawn if you are here to unwind at the end of a long day, or if you are settling in for the night with something gentle to listen to, you are in exactly the right place. These videos are made to feel like a quiet conversation with the universe itself, spoken softly enough that you can drift in and out as sleep arrives whenever it wants to. Tonight, we're exploring a question that sits beneath every other question in science. It hides under falling raindrops, glowing stars, peaceful mornings, and the steady tick of time. Why does reality follow rules? Why does the universe behave with such unwavering reliability, as if it has been practicing the same routines for billions upon billions of years without ever taking a day off? Before we wander too far into that mystery, I would love to know where you are watching from. It is always strangely comforting to imagine people listening from quiet bedrooms on the other side of the world, or from a sofa dimly lit by a warm lamp, or perhaps from a peaceful moment alone somewhere between one day ending and another beginning. Seeing all the different places these calm journeys reach is one of the loveliest parts of this channel. If these videos help you relax or ease into sleep, a like and a subscribe help more than you might imagine. And if you are already subscribed, thank you so much for supporting these peaceful explorations. Please do tap the notifications bell as well, so the next soft science story reaches you the moment it arrives. And if you enjoy drifting through calm explanations of the universe, you might also enjoy my other channel, The Sleepy Astronomer. It is a gentle space devoted entirely to the cosmos, where galaxies unfurl like quiet lanterns and distant worlds drift through the dark in slow, dreamlike arcs. If astronomy helps you relax, or if you simply enjoy the feeling of floating through the stars at bedtime, you may find it a soothing companion. And of course, the hope is always that this video feels soothing enough to help you drift off. Though, if it ends up being a little too interesting and keeps you awake longer than planned, at least you will slip into sleep with a few new ideas gently floating through your mind. I'll put the link in the description. So let your shoulders drop, breathe a little slower, and let the day fade away. Because tonight we're stepping into one of the deepest questions imaginable, wrapped inside the simplest moments of life. Why does the world behave so consistently? Why does reality not act randomly from one moment to the next? And if everything around you is following rules, who or what decided what those rules should be? When people talk about the rules of nature, it can sound as though the universe is following a strict instruction manual, as if someone wrote out a long list of commands and everything has been obediently carrying them out ever since. But natural rules are not like the rules in a classroom or the laws written in a book. They are not instructions that must be followed. They are quiet descriptions of how the universe behaves, observations of remarkable consistency woven into reality itself. They reveal patterns that remain true no matter where you are, no matter what century it is, and no matter who is watching. It is easy to imagine that rules require someone to enforce them, because that is how human life works. People create traffic laws, schools create codes of conduct, communities set guidelines for how to live together. These are prescriptive rules, invented to shape behavior towards some intended outcome. But natural rules do not work that way. No one stands over a falling stone to remind it to accelerate. No one lectures a beam of light about the speed it must travel. A cup of tea cools in the evening air, not because temperature laws have been imposed on it, but because the cooling happens every time, in every place, under every circumstance where the same conditions exist. Nature does not need reminders. It simply behaves in ways that are astonishingly consistent. This difference between human rules and natural rules is worth settling into for a moment. Human rules can be broken. They rely on choice. They depend on social agreement and enforcement. But natural rules cannot be disobeyed because they are not commands. They are the patterns that emerge when countless events unfold in the same way, again and again. They are not chosen. They are discovered. They are not enforced. They are observed. They are not brittle. They are woven into the structure of existence. What makes this particularly fascinating is that consistency itself is far from guaranteed. There is no obvious reason why nature should behave in the same way today as it did yesterday. Nothing outside the universe compels it to hold steady, yet it does. A pebble dropped from your hand will fall every time. Water will freeze at the same temperature every time. A warm room will cool slowly into the surrounding air in the same gentle curve of change every time. If you were to measure the brightness of a flame, the rustling of leaves, or the glow of the morning sky, the same underlying patterns would appear again and again. This persistence is not just helpful for understanding science. Without it, stars could not shine reliably. Seasons could not return. Life itself could not form or endure. Think about motion, one of the simplest places to see this. When something moves across a room, it does not behave erratically. It does not rush one moment, pause the next, and shoot off unpredictably its path. Its slowing, its collisions, all unfold in familiar ways. Even before people had words or theories to describe these behaviors, the patterns were there. They were faithful long before anyone recognized them. If you roll a ball across the floor, its slowing follows the same kind of curve every time. If you watch leaves fall from a tree, they drift downward in recognizable shapes, caught between gravity pulling and air pushing back. The world does not improvise new behaviors on a whim. Temperature is another soothing example. When something warm cools down, it always does so gradually, leaning closer and closer to the surrounding temperature in that same steady arc. You can heat water, let it stand on the countertop, and watch the warmth leave it in a slow, predictable flow. It cools the same way on a calm afternoon as it does late at night. It cools the same way in another country. It cools the same way on another continent. Temperature changes are not commanded. They follow patterns that emerge from the interactions of countless particles behaving consistently. Light is even more remarkable. No matter where it travels, no matter what medium it passes through, light behaves with exquisite reliability. You can take a torch outside, shine it into the night, and the photons leaving it will move with extraordinary precision. They do not wobble between speeds or hesitate before moving on. They do not race one moment and slow the next. They travel as if the universe has offered them a path that is always the same length for every tiny fraction of a second. This behavior does not come from a rule written somewhere. It comes from the nature of reality itself, a quiet rhythm that everything follows. Even everyday experiences are filled with these reliable patterns. A kettle whistles because steam expands in exactly the same way each time. A rainbow forms because light bends in predictable arcs when it enters droplets of rain. A shadow stretches across the floor because the sun moves in a steady path through the sky. You do not have to think about any of these processes for them to happen. They unfold according to patterns that have been present since long before there were kettles, raindrops, or shadows of any kind. The fact that nature could behave differently is part of what makes this so intriguing. It is imaginable, at least in theory, that the universe could choose chaos. It could allow stones to fall one day and float the next. It could let heat flow unpredictably. It could change the brightness of the sun from one morning to the next, but it does not. Instead, it selects consistency over complication, stability over randomness, and patterns over disorder. There is a quiet beauty to that choice, even if it is not a choice at all, but simply the way existence arranges itself. The idea that natural rules are discovered, not imposed, gives them a special character. They're not like inventions, they are more like shadows cast by something deeper. When early scientists measured falling objects or boiling water or beams of light, they were not inventing rules. They were recognizing what nature had been doing all along. They were translating consistency into language. They were noticing that the universe follows the same gentle rhythms everywhere you look. And perhaps the most calming thought of all is that the rules do not belong to any one thing. They are not the property of stones or stars or people. They are features of the universe as a whole. They connect tiny events in the everyday world with vast happenings across unimaginable distances. These same rules that guide the drifting of a falling seed also guide the movement of moons and the glow of starlight drifting across millions upon millions of miles. The same patterns that describe how warmth fades from a cup of tea also describe how stars cool over ages longer than all of human history combined. Natural rules are the universe behaving like itself. They give structure to existence, shape to experience, and meaning to change. They are the quiet promise that the world tomorrow will be recognizable to the world today. They are the reason you can breathe steadily, walk without surprise, look at the sky with understanding, and trust that the universe will continue to unfold with gentle regularity. And beneath all of that, there rests a quiet, lingering mystery. How did the universe become so consistent to begin with, and why did it choose this steady rhythm over an unpredictable one? Patterns are everywhere in nature, often so familiar that they fade quietly into the background. The same kinds of clouds gather when the air cools in the same way. The same shapes of waves arrive at the shore again and again, each one slightly different yet recognizably part of the same gentle rhythm. Morning light returns with such dependable softness that it almost feels inevitable. But beneath these calming repetitions lies a deeper question. Why do the same situations keep producing the same outcomes? Why does nature not grow tired of repeating itself, or decide to behave differently just once for no particular reason? The simplest way to understand this is to imagine nature as a vast collection of small events, each one following the same quiet tendencies. A wave breaking on the shore looks grand and powerful, but the behavior of that wave is shaped by countless tiny motions beneath its surface. Every drop of water flows because of the same forces. Every grain of sand shifts because of the same push and pull. When all the small parts act in consistent ways, the larger pattern appears naturally, not because something tells it to form, but because it could not form any other way. Repetition emerges from the reliable behavior of thousands upon thousands of tiny interactions. Think about the ocean for a moment. Waves appear to roll in with a steady beat, as though the sea is breathing in a slow, patient rhythm. Yet a wave is not a single object. It is a moving shape carried by water that never stays still. What gives waves their familiar form is the repeated way water responds to the wind above it and the gravitational pull beneath it. Every breeze brushing across the surface transfers energy in the same steady way. Every tug of gravity pulls each drop downward with the same gentle certainty. Nothing commands the ocean to move in those patterns. The patterns simply appear because all the forces acting on the water behave consistently, moment after moment, year after year. The same quiet logic guides the wind. On some evenings it drifts through the trees as a soft whisper, barely bending the leaves. On others it gathers itself into gusts that sweep across fields and hills, yet even in its wildness the movements of air follow patterns that repeat across the seasons. Warm air rising and cool air sinking create the same looping motions again and again. The air does not follow these motions because it chooses to. It follows them because of the simple way warm air expands and cool air contracts, and both respond in predictable ways to changes in pressure. From these tiny behaviors come the swirling shapes of breezes, the steady drift of evening winds, and the cyclical patterns of weather that return year after year. Daylight follows its own calm repetition. Every morning, the sky brightens in a slow, gentle sweep, following the rotation of the earth. It is the same every day, not because the world is trying to stay consistent, but because its motion is set by an enormous balance of forces acting over unimaginably long timescales. The earth turns with the steadiness of a patient dancer, guided by momentum that has carried it for billions upon billions of years. The sun rises in the same quiet arc, because the planet continues to spin in the same direction with the same speed, held in place by a balance that does not wobble or drift. The cycle is not commanded. It is simply the natural outcome of a world moving through space with steady grace. Weather patterns too are filled with repetition. Certain cloud shapes form when the air cools past a familiar threshold. Rain falls when moisture gathers beyond a certain point. Storms follow paths shaped by the turning of the earth and the distribution of heat across oceans and land. The weather may feel unpredictable from day to day, but the underlying processes are beautifully consistent. The unpredictability arises from complexity, not from any lack of order. Countless tiny pressures, temperatures and motions interact at once, and because each of those interactions follows the same rules every time, the overall system forms patterns that repeat across the seasons. When you step back and look at all of these examples together, waves, wind, daylight, weather, it becomes clear that patterns appear in nature not because they are commanded, but because they emerge naturally from stability. Whenever energy flows consistently, whenever matter responds predictably, whenever motion follows the same underlying structure, patterns arise like breath following breath. The universe does not need to decide what to do. It simply behaves according to the same deep tendencies again and again, producing shapes and rhythms that feel almost comforting in their familiarity. Imagine a hill covered in countless tiny pebbles. If it rains, the water flowing down the hill will carve little channels. If it rains again tomorrow, the water will follow those same channels, deepening them slightly. Over time, a single repeated behavior becomes a stable pattern, not because the water remembers what to do, but because the shape of the hill guides it. Nature is full of this kind of feedback where repeating actions reinforce the structure that encourages them. Patterns persist because they rest on foundations that support them naturally. Another gentle example can be found in sound. When you pluck a string, it vibrates at a very particular rate. If you pluck it again, it vibrates at exactly the same rate. There is no choice involved. The sound it makes depends on its length, its tension, and the material it is made from. These things do not change from one moment to the next, so the sound does not change either. Even a simple object like a string holds the essence of natural patterns. Repeated situations lead to repeated outcomes because the underlying structure remains the same. This idea reaches even deeper when you consider the behavior of matter itself. Everything around you is made of atoms that move, vibrate, and interact according to consistent tendencies. If you heat something, its atoms move faster. If you cool it, they slow down. These behaviors do not wobble between one rule and another. They do not react one way today and a different way tomorrow. They follow their patterns with remarkable steadiness, and from the combined motions of countless atoms, the familiar behavior of everyday objects emerges. The macro world, the world you can see and touch, exists because the micro world behaves the same way across every moment of time. Predictability in this sense is not something imposed on the universe. It is something that arises naturally from its stability. When the smallest building blocks behave consistently, the larger world shaped by them becomes consistent too. The reliability of waves, winds, seasons, and objects moving across rooms comes from the millions of tiny events happening beneath the surface. Each one follows the same quiet rules as the last. Each one nudges the world in the same direction. Each one supports the same patterns. And what makes this even more soothing is the thought that these patterns are not fragile. They do not depend on favourable conditions or rare coincidences. They persist because the universe's structure encourages them. Stability is woven through reality, allowing repetition to blossom in every corner of the natural world. Patterns appear because the universe behaves like itself, moment after moment, with gentle and astonishing regularity. It all leads to a simple but beautiful truth. Nature repeats itself because its foundations are steady. The smallest pieces follow the same quiet tendencies, and from these tendencies come the shapes, cycles, and movements that make the world familiar. Patterns are the universe's way of revealing that it is built on deep, dependable principles. Principles that form the backbone of every sunrise, every breeze, every wave, and every step through the quiet of the evening. Symmetry is one of those ideas that feels simple on the surface, yet underneath it lies something surprisingly deep. At its heart, symmetry means sameness under change. If you rotate something, or flip it, or shift it slightly, and it still looks the same, that object has symmetry. But symmetry is more than a visual pleasure or a pleasing shape. It is one of the quiet forces that makes the universe behave in stable and predictable ways. It is the hidden backbone that allows nature to repeat itself, balancing complexity with an underlying harmony that holds everything together. Imagine holding a snowflake between your fingers. Even though each one is unique, every snowflake carries a familiar repeating pattern. You can rotate it by a certain angle, and it seems to match itself again. That repeating shape is a kind of symmetry. The same goes for a seashell with a smooth spiral that can be turned or mirrored and still feels perfectly balanced, or the reflection of a mountain on still water, where the world above and the world below line up so precisely it becomes hard to tell which one is real and which one is the mirror. In each case, something changes, an angle, a perspective, a direction, yet the scene holds its structure. This sameness under change is more than aesthetic. It reveals that something deeper is at work. Symmetry in nature shows up long before we even notice it. The pull of gravity does not care which direction you face. It treats all directions equally. If you take a step to the left or the right, gravity responds with the same quiet tug downward. That is a symmetry of space. The world behaves the same no matter where you rotate yourself or shift your viewpoint. Light travels in straight lines whether you shine a torch north, south, east or west. That is another symmetry. Time, too, has its own kind of sameness. If you boil water today, it behaves as it did yesterday. If you drop a stone this afternoon, it falls in the same way it did this morning. The universe does not rewrite its behavior from one moment to the next. It behaves consistently across time, and that is a symmetry as powerful as any mirror or repeating shape. One of the calming insights behind symmetry is that it simplifies the universe. If the world behaved differently depending on which direction you faced, life would be astonishingly complicated. A torch shining upward might behave differently from a torch shining sideways. Pouring water might change depending on the hour of the day. Walking north could feel different from walking south. Every action would require endless attention because the outcome might shift for reasons no one could predict. Instead, the universe has chosen harmony. North, south, east, west. All directions are treated the same. Morning, afternoon, night. Time flows with the same steady rules. Because nature respects these symmetries, you do not have to relearn how the world works every time you move or turn or breathe. This sameness in how the universe behaves is not an illusion. It is a fundamental property built into reality. Space is smooth and even, not twisted or lopsided. Time runs forward with a calm and steady pace. Forces like gravity and electromagnetism respond consistently in all directions. These symmetries are what allow the universe to be understood at all. They remove unnecessary complexity, leaving behind elegant rules that hold true no matter where you stand or what direction you face. Think about rotating a simple object like a circle. No matter how you turn it, it remains a circle. Its symmetry makes it easy to describe because every direction through it is equivalent. Nature seems to prefer this kind of simplicity. Many things in the universe take on symmetrical forms, as if they are following a quiet preference for balance. Planets form into spheres, because gravity pulls equally in all directions, smoothing out lumps and irregularities over time. Stars form into spheres for the same reason even soap bubbles adopt spherical shapes, because surface tension acts symmetrically, pulling equally from every angle. The result is the most balanced form possible. Symmetry does not only shape visible forms, it shapes behavior. Because space treats all directions equally, objects in motion glide forward without bias. A rolling ball does not secretly speed up if it points north. A beam of light does not prefer one direction over another. Symmetry keeps motion simple and consistent. It ensures that the same causes lead to the same effects. If you push something gently, it responds in the same way regardless of where you are or which direction you push. You do not need to account for hidden preferences or uneven rules. The world remains stable because its symmetries prevent it from behaving unevenly. Symmetry in time is just as soothing. You can heat water and know it will warm at the same steady rate as it did yesterday. You can watch a pendulum swing and trust that the rhythm will match the rhythm it had the day before. The behavior does not depend on when you perform it. It depends only on the conditions themselves. This is a quiet blessing, because it means the universe does not shift its rules as the hours pass. The past, present, and near future all share the same fundamental structure. When symmetries are present, they guide nature toward balanced, repeatable behavior. They remove unnecessary variations. They strip away complexity that would otherwise overwhelm the world. They allow simple relationships to form between things. A swinging pendulum behaves predictably because time treats each moment equally. A drifting planet moves smoothly around its star because space treats every direction consistently. Light travels outward in perfect spheres because the universe offers no preferential direction. These behaviors feel harmonious because they are the natural result of symmetries shaping the interactions of matter and energy. Even the smallest pieces of reality respect symmetry. The particles that make up the world behave in ways that do not depend on where they are or how they are oriented. Their interactions unfold with the same quiet logic in every corner of the universe. You could rotate the entire scene of their tiny motions, and everything would continue exactly as before. This microscopic symmetry blossoms into the large-scale symmetry we see in the world around us. The repeating shapes of crystals, the even spreading of light, the calm strength of balanced structures. Symmetry gives the universe a steady framework on which everything else can build. What is especially striking is that symmetry is not just pleasing to the eye. It is the reason many rules of nature exist in the first place. When space treats all directions equally, the motions of objects become predictable. When time treats all moments equally, the unfolding of events becomes steady. When forces act without bias, the world becomes comprehensible. Symmetry quietly underpins the structure of reality, allowing nature to behave with a kind of calm, dependable rhythm. And perhaps the most poetic aspect of symmetry is that it offers a bridge between the simple and the profound. Rotating a snowflake, flipping a seashell, or admiring a mountain reflected in perfectly still water might feel like small, gentle moments. Yet they point to something vast. These small reflections of sameness reveal how deeply symmetry is woven into the fabric of the cosmos. The same harmony that makes a snowflake beautiful also helps guide planets in their orbits, shapes the behavior of light, influences the structure of atoms, and gives the universe the stability it needs to exist at all. In the quiet balance of these symmetries, nature finds a way to keep itself steady. It removes chaos by offering sameness where it could have offered disorder. It chooses harmony over complication, and from that harmony, the entire universe gains the gentle, repeatable patterns that make reality feel so familiar. In a universe filled with motion, change, and transformation, it can be comforting to realize that some things never truly disappear. They shift, they move, they exchange hands, but they are never lost. This quiet reliability lies at the heart of conservation, one of the most grounding ideas in all of physics. It tells us that certain quantities remain constant, no matter how dramatically the world rearranges itself. They are like silent anchors, holding reality steady while everything else flows and transforms. To understand conservation, it helps to picture something familiar. Imagine spinning on a smooth wooden floor. As you draw your arms closer to your body, you spin faster, and when you stretch them out again, you slow down. It feels almost magical, as though the spinning speed is responding to your gesture. But in truth, nothing mysterious is happening. Your body is simply redistributing something it already has. The total amount of motion that carries you around remains constant. It is only shared differently between your arms, your legs, and your core. Energy and momentum flow from place to place, but the total never changes. Even though the movement feels different moment to moment, the underlying quantity is conserved. This idea becomes even more soothing when you imagine something larger, like a drifting planet circling its star. As the planet travels through space, It speeds up slightly when it swings closer to the star's warmth and slows down as it drifts farther away. The motion feels like a quiet cosmic rhythm, nearer, faster, farther, slower. Yet beneath that gentle dance lies the same principle. The total amount of orbital motion remains constant. The planet trades speed for height, and height for speed, always keeping the sum steady. Energy flows smoothly through the orbit like water through a calm channel, reshaping the path without ever changing the final tally over billions upon billions of years. That balance keeps the planet in its graceful loop, neither falling into the star nor drifting endlessly away. Even flowing water carries the spirit of conservation. If you pour water from one cup to another, the shape changes, the surface ripples, the movement shifts, but the volume remains the same. The water does not vanish or multiply. It moves, it reshapes itself, it spreads or gathers, yet the total amount stays steady. Energy in flowing water behaves in a similar way. When a river rushes down a slope, water picks up speed. When it spreads across a flat plain, it slows again. But the total amount of energy moving through the riverbed remains constant, simply transformed from one kind of motion to another. The river never loses what it has, it only redistributes it. Conservation is nature's internal bookkeeping system. It keeps track of quantities that never vanish, even when they hide themselves in new forms. It ensures that when something changes somewhere, something else adjusts to balance it. If an object speeds up, something must have given it that speed. If one thing cools down, the warmth must have gone someplace else. If a force transfers energy, the universe keeps careful track. Nothing escapes the ledger. Nothing appears from nowhere or fades into nothingness. Conservation threads through reality like a quiet accountant, tallying every shift, every exchange, every transformation. This bookkeeping is not rigid or harsh. It is gentle, natural, and surprisingly elegant. Picture a child running with a paper pinwheel on a windy day. The air pushes the blades spin, and the child feels the slight tug of resistance in their hand. Energy flows from the wind into the pinwheel, from the pinwheel into the child's grip, from the child's grip into the ground with each step. In every moment, energy changes shape, but the total amount of that energy remains the same. Even when you cannot see where it goes, the universe knows, it always knows. These conserved quantities, energy, momentum, angular momentum, act as the deep stabilizers of reality. They keep stars shining steadily instead of flaring unpredictably. They guide planets in their paths instead of letting them wander. They allow everyday objects to behave consistently, giving the world a quiet sense of reliability. Even the warmth leaving a cup of tea as it cools is guided by conservation. The heat leaving the liquid enters the surrounding air, raising the temperature of the room by an amount too small to notice nothing is lost. It all moves onward, softly, invisibly, and yet faithfully. The idea becomes even more grounding when viewed across vast spans of time. Imagine a comet drifting through the solar system, guided by the same conservation laws that steered it during the age of early life on Earth. As it travels, it trades distance for speed and speed for distance, in a balance so steady it feels like breathing. The path may stretch and tilt, but the total motion never wavers. In the same way, the rotation of the Earth remains remarkably stable because of the conservation of angular momentum. Each sunrise, each tide, each gentle turning of the planet is governed by a quantity that has remained constant since long before the first oceans formed. Stability on this scale brings a sense of calm to the universe. A star does not suddenly lose its mass without a reason. A planet does not suddenly speed up without something to push it. A drifting asteroid cannot change course without a force acting upon it. Conservation acts as a quiet guide, ensuring that every change has a cause and every cause has an effect. It is the invisible structure that makes reality understandable. For something so abstract, conservation feels surprisingly tangible. When you look at the world through its lens, think of a spinning ice skater gliding across a frozen lake. As she draws her arms in, she spins faster, not because she creates more motion, but because the motion she already has becomes more tightly packed. When she extends her arms, the spinning spreads out again. It is the same amount of spinning, simply rearranged. The lake, the cold air, the glowing sky above, all of it becomes a backdrop to a demonstration of one of nature's gentlest principles. Or imagine a lantern set on a wooden table glowing softly in the evening. The energy inside the lantern shifts constantly. Heat flows upward, light spreads outward. The flame flickers in response to tiny shifts in air. Yet the total energy involved in these changes remains in perfect balance. The lantern glows because energy transforms, not because energy appears. Even in something as small as a flickering flame, conservation hums beneath the surface. These quiet exchanges are happening everywhere, all the time. Every movement of your body is guided by conservation. Every breath shifts energy through your chest. Every footstep passes momentum from your legs into the ground. The world is full of tiny trades, tiny adjustments, tiny balances, and behind all of them is a simple truth. Nothing ever disappears completely. Everything transforms, and those transformations always add up. Conservation does not force the universe into stillness. It allows the universe to move gracefully without losing its footing. It lets stars burn, planets drift, rivers flow, and people breathe, all without chaos or imbalance. It provides the rules that keep everything together while still allowing change, transformation, and life to unfold with freedom. It is a calming thought that beneath the whirl of existence, beneath the rushing of time and the shifting of matter, there are quantities that remain steady, untouched by the chaos above. They are the quiet anchors of reality, holding everything in place across moments, days, ages, and entire cosmic eras. In their steady presence, the universe finds a way to be both dynamic and dependable, both ever-changing and ever-familiar. There is something quietly poetic about the way humans look at the world and try to put its behaviors into words, symbols, and ideas. For as long as people have watched raindrops fall or stars drift across the night sky, there has been a soft question humming beneath it all. Are we discovering rules that already exist out there in the fabric of reality? Or are we inventing clever ways to describe patterns we observe? Do the laws of nature live independently of us, waiting to be found? Or do they take shape only when the human mind tries to make sense of the world? This is not a question with a simple answer, and that is part of its charm. It sits somewhere between philosophy, science, and the quiet human desire to understand what lies beneath experience, to explore it. It helps to begin with how people describe natural behavior in the first place. For centuries, mathematics has been the language used to uncover the structure of the universe. It offers a calm, crisp way to express patterns that would be difficult to put into ordinary words. A falling object speeds up in a particular way. A warm cup cools down with a gentle curve. A planet moves along a smooth path shaped by the pull of its star. Each of these processes unfolds with elegant regularity, and mathematics is a way of capturing that regularity and giving it shape. But here is something important to remember. Equations are not the rules themselves. They are shadows of deeper truths. They are reflections of how reality behaves, not the source of that behavior. When someone writes down a formula for how something moves or how something heats or how something shines, they're not commanding nature to follow it. They're simply describing as precisely as possible what nature already does. The equation is a translation, not the original. It is a map, not the landscape. This distinction brings us to the heart of the philosophical puzzle. When you describe the arc of a thrown stone with mathematical expressions, are you revealing an invisible rule that existed long before you, or are you creating a sophisticated framework that helps make sense of what you have seen? In everyday life, this might seem like a small difference, but in the quiet hours of the night, it becomes a fascinating one. If the rules are discovered, then the universe carries its own logic, independent of the minds trying to comprehend it. If the rules are invented, then the patterns of nature exist. But the shape of the explanation is something humans overlay onto the world like a transparent sheet. Consider for a moment the way people once described the heavens. A very long time ago, the night sky seemed to move around the earth, and early observers imagined it as a great dome with stars embedded like lanterns. The pattern was clear. The stars rose in the east and set in the west. But the explanation was an invention shaped by the understanding of the time. As observations grew more precise, the description evolved. The Earth was recognized as round, then as a world orbiting the Sun, then as a planet part of a much vaster collection of stars. The pattern never changed. The stars continued rising and setting in the same smooth sweep. Yet the framework humans used to describe that motion shifted dramatically. This gentle evolution shows that descriptions may be invented, but the underlying behaviors, the rising and setting, the slow drift of constellations, are discovered parts of reality. Another soothing example is the way people understood falling objects. For many centuries it was believed that heavier things fell faster simply because they contained more of their natural tendency to move downward. That was the explanation invented to make sense of what was observed. But when clearer experiments were performed, a deeper truth emerged. Objects fall in the same way regardless of weight. Unless air slows them differently, the pattern was always there. It was just described differently at different points in time. This makes it feel as though nature has its own quiet set of behaviors waiting to be uncovered, even if the human explanations for them shift and grow. Some thinkers believe that the rules of nature are woven into the universe, whether or not anyone is around to notice them. In that view, the patterns of gravity, light, heat, and motion existed long before people began measuring or naming them. The universe behaved according to its own logic when Earth was still cooling, when the first oceans formed, and when the earliest life began to stir. Humans arrived much later, observing these behaviors and trying to capture them with language, symbols, and eventually equations. In that sense, the rules are discovered, patiently waiting to be understood. Others suggest that while the behaviors are real, the rules we write down are inventions, models of how the world appears to work, refined over time as our tools and insights improve. In this view, the universe does not carry equations inside itself. It simply behaves, and humans create mathematical frameworks that approximate those behaviors. These frameworks grow more accurate as understanding deepens, like an artist gradually improving a portrait. The closer the drawing becomes to the real person, the more it feels like a discovery. Yet it is still, in some sense, a creation, Perhaps the truth sits somewhere in the middle. Nature offers the patterns, humans offer the language. The universe moves, glows, cools, and orbits with quiet consistency. People then try to describe these motions using symbols that feel elegant and precise. Sometimes the descriptions work beautifully, as though capturing the very heartbeat of reality. Other times they fall short, revealing that the world has more to say than the equations allow. In this gentle back and forth discovery and invention weave together, what makes this debate especially calm and lovely is that no matter which view one leans toward, the central experience remains the same. The world behaves with astonishing regularity. Whether the rules are found or crafted, they help illuminate the underlying harmony of nature, and they keep evolving just as human understanding evolves. If you follow this idea through history, you can see how beautifully the interpretations have shifted. Early astronomers tracked the sky with nothing but careful eyes and simple tools, slowly recognizing patterns in the wandering of planets. Centuries later, more refined instruments revealed deeper details: elliptical orbits, gravitational interplay, the quiet dance of celestial bodies. And later still, sophisticated theories offered even more nuanced explanations. At each stage, people believed they were getting closer to something fundamental, yet their descriptions continued to evolve. This slow, patient refinement is not a failure of understanding. It is a sign that the universe is generous enough to reveal its patterns gradually, allowing each generation to add another layer of clarity. In the end, the question of whether rules are discovered or invented may not need a firm answer. It may be enough to appreciate the way they allow us to make sense of the world, the laws of nature, whether they live inside reality or inside our descriptions, offer comfort. They reveal that the world is not chaotic, that it follows rhythms and tendencies that can be understood, even if only partially. They offer a way to translate the quiet consistency of existence into something graspable. As you think about this, you might find your mind wandering to the space between discovery and invention, that soft, uncertain place where questions drift like smoke. The universe behaves the way it behaves. Humans simply try to listen, and in the space between those two things lies a kind of wonder, calm, open, and endlessly inviting. Chaos is one of those ideas that sounds wild and unruly, as if it describes a world without structure or sense. But in truth, chaos does not mean disorder in the way people often imagine it. It does not mean randomness or lawlessness or nature behaving without purpose. Chaos is much quieter and far more interesting. It is what happens when predictable rules meet tiny differences. It is sensitivity, not madness. A system is called chaotic when its behavior depends delicately on its starting conditions, so finely tuned that a change as small as the flutter of a leaf or the warmth of a passing breath can shift the outcome in unexpected ways. This is why chaos often feels surprising. The rules beneath it remain steady and reliable, but the world they shape can unfold in ways that seem unpredictable. It is like placing two identical boats on a river that looks calm at first glance. If one begins its journey a tiny bit ahead of the other, or a fraction closer to one bank, the flow of the water may carry them along paths that start similar but slowly drift apart. Minor differences grow as they travel forward, not because the rules of the river change, but because their journey amplifies the smallest variations. Weather is perhaps the gentlest and most familiar example. On some mornings the air warms evenly, the clouds drift softly, and the day unfolds in a predictable arc. On others, the atmosphere behaves just a little differently. An updraft here, a puff of cold air there, and suddenly the sky tells a different story. A cloud that might have evaporated instead thickens. A breeze that might have remained mild becomes a gust. A storm that might have drifted away forms instead. The rules of weather never change. Warm air rises, cool air sinks, moisture condenses, pressure balances itself. But these simple rules interact across billions upon billions of molecules, and if the starting point shifts even slightly, the final outcome can be noticeably different. This is sensitive dependence on initial conditions, the heart of chaos. If you begin with the tiniest change, the results can grow apart until they become entirely distinct. It is not randomness, but a delicate branching of possibilities. Nature follows the same rules each time, but because the starting details are never perfectly identical, the outcomes drift. You can see the same behavior in something as small as a candle flame. Watch a flame flicker in a quiet room. One moment it leans slightly to the left, then it straightens, then it sways to the right, as though responding to a rhythm too subtle to hear. Yet beneath that gentle dance lies a simple structure. The heat rises, the cooler air falls. The shape of the flame responds to tiny variations in airflow, variations so small you could never hope to replicate them exactly. Even the warmth of your hand, held at a distance, changes the pattern. Wave your fingers lightly near the flame, and the shifting warmth creates a cascade of effects. The flame responds immediately, but each flicker obeys the same basic rules of heat, buoyancy, and airflow. Swirling leaves in a light breeze behave in much the same way. Each leaf moves according to simple principles. It catches the wind, it rotates in response to uneven edges, it drifts downward under gravity. But because no two leaves begin from precisely the same angle or shape or height, their paths diverge almost immediately. One leaf may spiral gently, another might flutter unpredictably. The rules are identical, but the outcomes vary because the starting points cannot be perfectly matched. Even the smallest difference, one corner curled slightly more than another, leads to a unique and graceful path through the air. This is the quiet beauty of chaos. It shows how sensitive the universe can be to the smallest details, while still following its rules with absolute consistency. The unpredictability does not come from nature abandoning its laws. It comes from the way countless interactions build upon one another. A chaotic system behaves like a whisper passed from ear to ear in a long line of listeners. The message is shaped by each person who hears it. A tiny shift at the beginning leads to a large shift at the end, even though every listener follows the same routine: hear, interpret, repeat. But despite its unpredictable surface, chaos always has deep order at its core. The motions of weather systems follow the same fundamental behaviors, no matter how different the outcomes look. Candle flames may flicker in countless ways, but the physics guiding them never wavers. Leaves spiral unpredictably, yet the forces that move them remain steady. Chaos does not erase the universe's consistency. It reveals how deeply that consistency runs. Even when outcomes vary wildly, the rules remain gentle, patient, and unchanging. Chaos also shows how complexity can emerge from simple rule sets. Imagine a simple system where a point moves based on 3 or 4 straightforward instructions. If the rules are chosen carefully, the movements of that point will trace out intricate shapes that never repeat but remain confined to a particular region, forming patterns that look both orderly and endlessly surprising. These shapes, known as strange attractors, illustrate the heart of chaos, structure within unpredictability, order hidden inside complexity. The rules guiding the system remain fixed, but the unfolding motions weave through a space where no two paths are ever exactly the same. This kind of behavior appears all across nature. A coastline may look jagged and irregular, yet its structure arises from simple actions of waves breaking along the shore. The branching of a tree might seem too complex to follow, yet each branch grows by responding to light, wind, and small variations in its environment. Even the fluttering path of an insect in flight follows consistent rules as it responds to scents, currents, and tiny shifts in the air. Chaos is the natural outcome of many simple behaviors interacting at once, each one amplifying the smallest changes. It can feel comforting to know that beneath even the most unpredictable scenes, the universe remains lawful. Nothing in a chaotic system happens without reason. The reasons are just too numerous and too finely detailed to track perfectly. The unpredictability comes not from randomness, but from the intricate sensitivity of natural processes. In this way, chaos reminds us that the world is not as wild as it appears. It behaves according to rules, even when those rules create outcomes that look irregular. And there is something deeply calming about that. The flame dancing on a candle wick is not erratic. It is obeying physics with exquisite precision. The swirling of leaves on an autumn day is not disorderly. It is the graceful response of each leaf to the shifting air. The clouds forming overhead are not chaotic in the sense of being lawless. They are shaped by millions of tiny temperature shifts, each one following consistent patterns. Chaos teaches that unpredictability and order are not opposites. They coexist, they blend, they rise from the same source. Predictable rules can build unpredictable worlds, not because they falter, but because the world is subtle enough that the smallest details matter. And in that gentle mix of order and unpredictability lies a kind of natural poetry, reminding us that even the most surprising moments in nature are guided by steady, dependable laws woven quietly beneath the surface. There is a gentle kind of wonder in discovering that the world's most intricate patterns often begin with the simplest ingredients. When you look closely at nature, it becomes clear that complexity is not built from complicated instructions. Instead, it rises from countless tiny behaviors, each one soft and simple, layering together until something rich and surprising appears. Beneath the tangled forests, the twisting rivers, the branching lightning, and the curling frost on a winter window, the universe hides a preference for simplicity. It repeats the same quiet rules again and again until they blossom into patterns so detailed they look almost handcrafted. One of the clearest ways to see this is through shapes known as fractals. A fractal is a pattern that grows by repeating a simple rule over and over. Each repetition adds another layer of detail, like the branches of a fern that split into smaller ferns, which split again into even smaller shapes, each one echoing the ones before it. From a distance you see the whole plant. Up close you see the same graceful curves in miniature. It gives the illusion of incredible sophistication, yet underneath it lies a rule so small and quiet that it feels almost humble. A fern grows by dividing and repeating. Frost crawls across a surface by following temperature gradients. Lightning forks through the air by seeking the path of least resistance. Simple instructions, stunning results. Branching rivers offer another gentle example. When rain falls on a landscape, the water flows downhill, always choosing the easiest path. It joins with other trickles, forming streams that join into larger channels, carving their way through soil and stone. From a distance, the river system looks like a tree lying across the land, with countless branches feeding into a single trunk of flowing water. But the shape is not planned or mapped in advance. It is the result of a very simple behavior repeated endlessly. Water moves downward along the paths where it meets the least resistance that is the only instruction, and from that single tendency, entire river basins form, each one with its own character and flowing geometry. You can see the same principle on a cold morning when frost paints delicate patterns across a window. The icy shapes look like feathers or ferns or drifting smoke frozen in place. It is easy to imagine that something elaborate must be guiding the formation of these crystalline artworks. Yet frost grows because water molecules arrange themselves in the simplest way possible, lining up in patterns that minimize energy. As the frost spreads, the molecules keep repeating that same quiet tendency, building layer upon layer until something intricate appears. It is a reminder that beauty does not require complicated instructions. It emerges from the repetition of modest acts. Even the clouds drifting through the sky carry this theme. They swirl and billow with shapes that seem endlessly varied, yet their behavior is guided by a few straightforward rules. Warm air rises, cool air sinks. Moisture condenses into droplets when the temperature drops below a certain point. These tendencies repeat themselves in countless threads of air across the sky. The resulting formations look soft and mysterious, as though sculpted by an artist with a love for gentle curves. But they are simply expressions of the same behaviors unfolding over and over in slightly different ways. This idea that complexity can arise from very simple rules is known as emergence. It is one of the quiet wonders of the natural world. Emergence means that the behavior of something large cannot always be predicted by looking at its smallest parts. Even if each particle or droplet or leaf follows a straightforward rule, the combined effect can be astonishingly rich. It is like listening to a choir. Each voice follows a simple melody, but together they create harmonies that none of the individual singers could offer on their own. You can see emergence in the flocking of birds at dusk. Each bird flies by following three simple behaviors: keep a comfortable distance from neighbors, match their direction, and stay close to the group. That is all. And yet when hundreds of birds follow those rules at once, the flock becomes a shifting, flowing shape, twisting through the sky with movements that look almost alive in themselves. It feels like watching a single creature made of many smaller ones, but no leader guides it, no plan directs it. The beauty emerges naturally from the repeating of simple tendencies. The universe's preference for simplicity also appears in physics. Often, the most elegant explanations involve the fewest assumptions, the cleanest ideas, the simplest patterns. Light travels in the path that requires the least time. Objects move in ways that minimize effort. Planets follow orbits that rise from balancing only two influences: gravity pulling inward and momentum carrying them forward. These principles are so sparse, so restrained, that they almost feel like whispers. Yet from them come sunsets, seasons, eclipses, and the grand, slow spirals of galaxies. This tendency toward the simplest path is not laziness. It is a kind of natural efficiency, a way the universe reduces unnecessary complexity. If there are many possible ways for something to happen, nature tends to choose the one that demands the least energy, the least resistance, or the least complication. You can see this in the way soap bubbles form perfect spheres. The bubble stretches into the shape with the smallest surface area possible, because that shape costs the least energy. The result is both elegant and inevitable, a blend of simplicity and beauty that appears effortlessly. Hidden simplicity also appears in the patterns formed by living things. A single seed contains a pattern for how a tree will grow. The rules inside that seed are modest: divide, grow, respond to light, strengthen where needed. Yet from those instructions emerge towering forests with twisting branches, fluttering leaves, and deep root systems spreading beneath the soil. Complexity blooms from quiet beginnings. Even the structure of your own body is shaped by simplicity. Cells divide and specialize based on signals that follow straightforward pathways. Muscles contract because of basic chemical reactions. Your heartbeat follows a repeating cycle shaped by electrical impulses that operate without conscious direction. From a handful of simple biological rules comes the entire orchestra of life: breathing, thinking, moving, feeling. Complexity does not overshadow simplicity, it grows from it. In a way, this hidden simplicity is comforting. It means the universe is not as tangled as it appears. Beneath the surface, at the core of every unfolding pattern, lies something clean and straightforward. Complexity is not chaos. It is order, built layer by layer, one simple behavior stacked upon another, until the whole becomes too intricate to trace with the eye. And there is a quiet beauty in knowing that behind every frost pattern, every curling cloud, every branching river, and every heartbeat lies a small handful of tendencies repeated patiently across time. It invites you to look at the world differently, to see the simple threads weaving through the fabric of reality. The world may look elaborate, but deep down it is guided by patterns that are soft, graceful, and remarkably simple. When you notice this, complexity becomes less overwhelming and more like a kind of natural music. Each note is simple, but together they create a melody that fills the world. And beneath that melody lies a steady rhythm, the quiet pulse of simplicity shaping everything that exists. The universe is always moving. Stars drift through their galaxies, planets sweep along their orbits, clouds of gas swirl, collapse, and eventually ignite into new suns. Even the atoms in your body tremble with tiny vibrations that never entirely stop. With all this motion, it might seem surprising that the universe manages to remain so stable, yet it does. Despite the constant flow of matter and energy, the laws that guide everything hold steady, as though written into the deepest fabric of reality. This quiet steadiness allows the cosmos to evolve without losing its balance, growing and changing while still following the same familiar rules. One of the most calming examples of this stability is the way planets move around their stars. Imagine a planet gliding along its orbit, tracing a gentle curve through the darkness. Nothing rushes, nothing jolts. The planet moves because of two simple tendencies: the pull of gravity and its own motion carried forward. These two forces remain so constant, so unchanging, that they create a stable path that can last for billions upon billions of years, even as the planet ages, even as its surface changes and its atmosphere shifts. The orbit remains steady because the rules guiding it do not drift. Gravity does not decide to suddenly strengthen on a whim. Momentum does not forget what it is meant to do. The path endures because the universe stays consistent. Star formation follows this same kind of quiet logic. A cloud of gas floating in space may drift undisturbed for a very long time, long enough to make even the most patient person raise an eyebrow. Yet eventually, tiny fluctuations grow as gravity begins to draw the cloud inward. Slowly, steadily, the cloud collapses. It warms, it spins, it forms a new star. Every stage unfolds according to the same rules that shape the very first stars in the universe. There are no shortcuts, no sudden leaps. Nature takes its time, following the same gentle principles that have been present since the earliest ages of existence. If the universe had a motto, it might very well be something like, "No need to rush, we have all the time in the world." Once a star ignites, it shines by fusing light elements into heavier ones, a process that continues with serene predictability. Hydrogen becomes helium, helium becomes heavier elements. Over time, these elements drift outward when the star sheds its outer layers or ends its life in a brilliant release of energy. Those elements become part of new clouds, which become part of new stars, planets, oceans, and living things. This elemental cycle is one of the most orderly systems in existence, yet it unfolds over periods so long that human history barely makes a ripple in comparison. The rules guiding these transformations, how atoms fuse, how stars shine, remain unchanged through all of cosmic time. From the first stars that ever formed to the ones shining above you tonight, the same gentle processes remain at work. Long-term stability often arises from the way local rules combine. Each gas molecule in a cloud behaves in a simple way. Each grain of dust in a forming planet follows a straightforward path. Each atom in a star obeys basic tendencies of attraction and repulsion. These small, reliable actions accumulate into grand structures that endure across ages. It is like watching a mosaic form from many tiny tiles. No single tile reveals the full picture, but when many gather together in a consistent way, something majestic appears. The stability of the universe is not imposed from above. It emerges from millions of tiny behaviors acting together with unwavering regularity. Consider the quiet stability of elemental balance. The elements that make up the world, oxygen in the air, carbon in living things, iron in the core of a planet, exist because stars forged them according to predictable nuclear processes. These processes do not shift from star to star, nor do they drift as the universe ages. The same reactions that occurred in the first generation of stars continue today, following patterns so faithful they could be mistaken for a cosmic rhythm. This steadiness is part of what allows life to flourish. If the rules change constantly, chemistry itself would become unreliable. Water might behave differently from one day to the next, elements might react unpredictably. Life would struggle to find its footing. But because the rules hold steady, everything built upon them finds stability too. Even the slow drift of galaxies behaves according to constant rules. Gravity shapes their paths, encouraging clusters of stars to gather together in spirals, ellipses, and sweeping arcs. These grand forms evolve slowly, taking unimaginable stretches of time to shift and transform. Yet the underlying principles remain unchanged. A star at the edge of a galaxy follows the same tendencies as one near its core. The rhythm is slow, patient, and immensely graceful, like a cosmic waltz unfolding in the background of time. It can be comforting to realize that while everything moves, nothing moves without guidance. The stability of the universe is not fragile, it is resilient. It continues through change because change itself follows patterns. A leaf falling from a tree sways and spirals, yet always follows the pull of gravity. A comet approaching the sun warms and releases gas, forming a tail that always points away from the star. The path may look dramatic, but the underlying rules are the same ones guiding planets, moons, and drifting stardust. There is a gentle humour in how long these processes take. Stars do not hurry. Galaxies do not rush to rearrange themselves. Even a planet's orbit changes only very slowly over millions of years, adjusting so gradually that an entire civilization could rise and fall without noticing anything more than the usual turning of the seasons. If the universe had a sense of comedic timing, it might smile at our impatience. While people count their lives in decades, the cosmos seems perfectly content to accomplish its work over spans that make even the most patient clock look hurried. Yet this is not laziness. It is the natural consequence of stability stretched across enormous time. Even so, the universe does not stand still. Stars burn and fade, orbits shift slightly, elements transform, galaxies drift. Yet through all these changes, the laws themselves remain firm. They're like the foundations of a building that constantly remodels itself without ever altering its groundwork. Because the rules stay steady, the changing universe never slips into chaos. It evolves rather than collapses. It transforms rather than unravels. This long-term stability allows the universe to grow more interesting with time. The first moments after the beginning were simple and hot, filled mostly with light elements. But because the rules remained constant, those elements combined, interacted, and eventually formed everything, from clusters of galaxies to rocky planets to the molecules that make up life. Each stage built upon earlier stages. Each step followed patterns that never wavered. There is something calming in all of this. Beneath the motion, beneath the constant shifting of matter and energy, there is a deep steadiness, a quiet constancy, a sense that the universe is trustworthy, reliable, and patient. It may take its time, indeed it takes all the time there is, but it never rushes, never jolts from one set of rules to another. Change unfolds within a framework that is itself unchanging, and because of that, the universe becomes a place where growth can occur, structures can endure, and life can arise on planets quietly circling their stars. In this way, stability and motion are not opposites. They are partners. The universe keeps moving, flowing, and transforming, yet it does so on a foundation that holds steady beneath it all. That steadiness is what allows everything else to flourish, and woven into that harmony is a gentle truth. Even in a cosmos that is always in motion, the rules that guide it remain beautifully, quietly constant. It is a soothing thought that the universe behaves with such steady grace, following patterns that allow stars to shine, planets to form, and life to drift into existence. Yet it is just as calming and strangely awe-inspiring to imagine how delicately balanced these patterns truly are. A small shift in the underlying rules could produce a universe so different that it would be almost unrecognizable, the same way a single brushstroke can change the feeling of a painting. A tiny adjustment in the laws of nature could transform the entire character of reality. Imagine, for instance, a universe where the forces that bind atoms together were only a touch weaker. Atoms rely on a gentle balance between attraction and repulsion, like dancers holding hands while spinning in a slow circle. If that pull were weakened only slightly, the dancers would slip apart. Atoms would not hold together long enough to form structures. Matter would still exist, but it would crumble into a drifting mist of particles that never settle into stars, planets, or anything solid. There would be no warm surfaces, no oceans, no mountains, no quiet corners of the world where life could take a breath. A universe could float endlessly without ever forming something as simple as a pebble. Or picture a universe where the same atomic forces were just a little stronger. In such a place, atoms would cling too tightly. Nuclear reactions inside stars rely on a delicate balance, a threshold where fusion can occur without becoming too violent or too faint. If the forces binding atomic nuclei were slightly stronger, stars would have to burn far hotter to overcome their internal pressure. They might flash into existence only briefly before tearing themselves apart under their own intensity. In such a cosmos, stars would not shine steadily for billions of years. They might instead flicker like sparks in a dark wind, bright for a moment, gone the next, leaving no lingering warmth for planets to orbit. There are even hypothetical universes where stars cannot shine at all. In some imagined realities, the force that governs how particles decay is set differently. If this force was stronger or weaker by a small fraction, the chain of reactions that allows stars to produce light could break. The sky would never brighten. Darkness would be the permanent backdrop. Matter might gather into clouds, but without the slow, steady fire of starlight, those clouds would never warm or ignite. The universe would be a quiet abyss, vast and cold, without the twinkling points of light that make our night sky feel so familiar. These ideas can sound dramatic, but they arise from gentle, responsible speculation, simple explorations of how nature's rules fit together. Every rule interacts with every other one, forming a balanced web of behaviors. Adjust one thread, and the entire pattern shifts. You can think of it like a mobile hanging from the ceiling. Each piece depends on the tension of the others. A small adjustment to a single ornament can tilt the entire structure. The universe behaves the same way. Change the strength of gravity by a tiny fraction, and stars might collapse more easily or fail to form entirely. Adjust the way light interacts with matter, and atoms might glow differently or lose their ability to emit radiation at all. Shift the balance between expansion and attraction in the cosmos, and galaxies might never coalesce, leaving a featureless haze instead of the grand spirals and glowing clusters we see today. In some imagined universes, gravity might be too strong. If that were the case, everything would rush together quickly after forming. Stars might swallow their planets, galaxies might curve in upon themselves, and black holes could dominate the cosmic landscape. The entire universe might become a dense, dark place where matter has no space to breathe or spread. In other universes, gravity could be too weak, causing matter to drift apart without ever condensing into stars or planets. The cosmos would stretch endlessly, filled with diffuse clouds that never gather enough weight to ignite. Such a universe would be quiet, gentle, and almost empty. A soft theatre waiting for actors that never arrive. Even the way chemistry works depends on fine-tuning. The familiar table of elements, with its wide range of behaviors, appears only because the underlying laws land in a precise balance. Adjust that balance, and chemistry could become extremely simple or impossibly complex. There might be only a handful of stable elements, or thousands of unstable ones that flicker into existence before dissolving. Molecules might fail to form in the ways we recognize, preventing the building of structures like DNA, proteins, or even simple crystals. The richly textured world of materials, water, metal, stone, air, could vanish entirely. Thinking about these alternate possibilities is not about imagining chaos or indulging in bleak scenarios. Instead, it highlights something quiet and profound. Our universe is balanced in a way that allows complexity to appear. It allows stability and change to coexist. It allows stars to shine with gentle persistence. It allows planets to form with the right conditions for oceans, weather, and eventually life. It gives matter the freedom to organize itself into everything from drifting clouds to thinking beings. That balance is delicate, but it is also incredibly robust. Robust enough to survive across billions of years, guiding the cosmos through its long history without losing its harmony. There is something poetic about how narrow that balance can be. A small nudge in any direction, and the universe transforms into something entirely new. A slight adjustment of one rule, and the story of creation unfolds differently. Yet in every version of these hypothetical universes, the rules remain consistent within themselves. Even a universe without stars would still follow its own steady logic. Even a universe where atoms collapse or expand endlessly would behave predictably according to its altered foundations. Each universe would have its own character, shaped by the same quiet principles of consistency and structure. Contrasting these possibilities with our own world deepens the sense of admiration for the reality we inhabit. Here, the stars shine softly for billions of years. Here, atoms bind with just the right strength to form materials sturdy enough for mountains, flexible enough for trees, and delicate enough for life. Here, the glow of starlight warms distant planets, and the flow of energy shapes climates, oceans, and living rhythms. Our rule set is neither too harsh nor too gentle. It is tuned to create a universe rich in light, structure, chemistry, and possibility. The existence of these alternate scenarios is not meant to suggest that our universe is perfect or privileged. It simply shows how finely balanced the laws of nature are, how they work together like instruments in an orchestra to create a harmonious whole. A single instrument changed in pitch or tempo would create a different song entirely. The universe we know is one particular melody in an endless possible symphony, and within that melody, every star, every atom, every living thing plays its part. Thinking about alternate universes invites a quiet sense of perspective. It encourages a moment of stillness, the kind where you lean back and feel the softness of the world around you. You can imagine other realities, each one following its own set of gentle rules. And in doing so, you come to appreciate the delicate balance of the one you call home. A universe where starlight warms distant worlds, where matter forms stable patterns, and where life finds a way to flourish under the glow of a sky filled with steady, dependable stars. Beauty often feels like something mysterious, as though it appears out of nowhere, a sudden shimmer that catches the eye and calms the mind. Yet when you look closely at the shapes that humans tend to find beautiful, a quiet truth emerges. Much of what feels beautiful in the world arises from consistency. The same rules that give nature stability also shape the recurring forms that appear again and again across the cosmos. Spirals, spheres, branching patterns, ripples, rings. These soothing shapes are not coincidences. They are the natural consequences of physical laws behaving with calm reliability, creating patterns that mirror themselves from the tiniest scales to the grandest stretches of space. Consider the gentle spiral of a seashell. As the creature grows, it adds new material at a steady rate, each curve gently extending from the one before it. The shell does not think about its shape or decide to form a spiral. It simply grows by repeating the same quiet process, adding layer upon layer in accordance with the simple rules of its biology. The result is a shape that feels both elegant and inevitable. Humans find these spirals calming because they echo a kind of natural logic, a form that grows smoothly, predictably, and without abrupt change. The same pattern appears in the vast arms of galaxies. These immense spirals, stretching across hundreds of thousands of light years, arise from stars orbiting around a dense center. The stars follow the rules of gravity and motion, each one responding to the others as they slowly drift around the galaxy's core. Over unimaginable spans of time, this interplay of motion shapes the stars into spiraling arms. These arms are not rigid structures. They are waves of density, echoes of movement. The shape is created not by deliberate design, but by the patient unfolding of consistent laws, and yet the result is breathtaking. A cosmic spiral that resembles the curve of a shell found on a quiet shoreline. Spherical forms are another product of nature's reliable simplicity. A sphere appears whenever a shape is pulled equally in all directions, whether by gravity, pressure, or surface tension. That is why planets and stars become round over time. Gravity tugs uniformly, smoothing out irregularities until the world becomes a soft, balanced sphere. Even a soap bubble floats as a perfect sphere, because surface tension pulls the bubble's surface into the form with the least energy. The shape is calming because it represents balance, every point equally distant from the center, every direction treated the same. Spheres feel complete, whole, and gently satisfying, as though nothing could be added or taken away without breaking the harmony. Branching patterns follow a similar kind of quiet logic. Trees grow branches that divide again and again, mirroring the way rivers split into tributaries and lightning forks through the sky. These forms look complex, but they arise from simple tendencies repeated repeatedly. A river splits because water follows paths of least resistance. Lightning branches because electric charge seeks multiple routes through the air. Trees divide their branches to maximize sunlight and support. Each process is straightforward, but when repeated many times, it creates patterns that feel intricate and alive. Humans find branching forms soothing, in part because they resemble natural growth, spreading outward gently with no abrupt or chaotic turns. Auroras offer a softer kind of beauty, one shaped by charged particles dancing along magnetic field lines. When these particles reach the upper atmosphere, they collide with gas molecules, releasing delicate curtains of coloured light. The patterns shimmer, sway, and ripple in ways that appear almost improvised. Yet beneath their fluid grace lies rigid consistency. The lights follow magnetic lines that never waver. The colours arise from atoms behaving in predictable ways. Even the flickering rhythm is guided by steady flows of energy from the sun. The aurora feels magical because it combines deep reliability with delicate movement. A performance choreographed by physics but expressed with artistic softness. Crystalline structures bring the idea of beauty through consistency down to the scale of the very small. A crystal forms when particles settle into repeating patterns that minimize energy. Snowflakes, salt crystals, gemstones, frost. Each one is an expression of a simple underlying rule. The molecules line up in the same arrangement over and over, building outward in patterns that repeat across entire structures. Snowflakes, in particular, blend symmetry and variation in a way that captivates the imagination. Each one follows the same basic rules, yet tiny changes in temperature and humidity create endless unique shapes. The balance of repetition and surprise make snowflakes especially calming. They show that even within strict rules, infinite possibilities can bloom. Humans often find patterned things calming because patterns feel dependable. They reveal that the world is not chaotic, that it follows rhythms and structures that make sense even if we cannot always articulate them. When someone admires the spiral of a fern unfurling in spring, or the ripples left behind by a pebble in a still pond, they are seeing consistency made visible. Their mind relaxes, recognizing that the unfolding shapes are guided by gentle, predictable rules. There is something deeply reassuring about this connection between consistency and beauty. It suggests that the universe is not random in its artistry. It creates forms that feel elegant precisely because the underlying rules are stable and balanced. The spiral of a hurricane and the spiral of a seashell are wildly different in scale, yet both emerge from the same kind of mathematical beauty. The spherical shape of a raindrop mirrors the shape of a star. The branching pattern of a lightning bolt echoes the branches of a tree. These parallels are not coincidences, they are reflections of how nature organizes itself, using the same gentle principles across countless contexts. When you begin to see these recurring shapes, the world takes on a quiet sense of unity. The patterns that guide the formation of clouds are related to the patterns that guide the arrangement of galaxies. The same kind of branching that shapes rivers shapes coral reefs and the blood vessels beneath your skin. Beauty becomes a kind of language, a soft whisper that connects the smallest and largest things in existence. And once you notice this whisper, it becomes hard to unhear it. The world begins to feel more interconnected, more harmonious, more deliberate in its elegance. This connection between beauty and consistency might also explain why humans often turn to patterns for comfort. Musical rhythms, repeating lines in architecture, balanced designs in art. These creations echo the same stability found in nature. They feel grounding because they resonate with the patterns woven into the universe itself. Even the simple act of watching waves roll onto the shore can bring a sense of peace. The waves may differ slightly each time, but their rhythm is steady. Their motion is guided by forces that never stray. Their repetition becomes a kind of visual lullaby. In this gentle harmony, the viewer is invited to drift not just into appreciation, but into understanding. Beauty is not accidental. It is a sign of consistency. It is the visible expression of rules operating quietly beneath the surface, and by noticing it, by pausing long enough to let these recurring forms settle into awareness, you become part of the same rhythm, an observer within a world shaped by calm, repeating patterns. As you let that thought soften in your mind, the beauty around you becomes even richer. Every spiral, every sphere, every branch becomes a reminder that the universe finds elegance in simplicity and strength in consistency. It finds ways to repeat itself without ever becoming dull. It finds ways to generate endless variety from a handful of reliable rules. And in that steady unfolding of patterns, there is a deep and gentle assurance that the world is shaped by order. An order that is as beautiful as it is dependable. The rules of nature feel so steady that it is easy to imagine they have always been exactly as they are now. Gravity pulls with the same soft strength. Light travels with the same quiet speed, atoms bind with the same delicate balance. From our perspective, the universe seems anchored in consistency, yet some scientists have gently wondered whether these rules have always been identical, or whether they might slowly evolve over vast stretches of time, not in sudden leaps or dramatic shifts, but in quiet drifts so slow they would escape all but the most careful attention. To explore this possibility, it helps to picture the early universe, a time when everything was hotter, denser, and simpler. Close your eyes and imagine a warm, glowing fog filling all of space. No stars, no planets, no galaxies sweeping in graceful spirals, just a thick sea of light and particles, drifting in ways that feel more like a softly simmering ocean than the vast cosmos we know today. In such an environment, the familiar structures of the modern universe could not form. Temperatures were too high, particles were too energetic, even the simplest atoms struggled to hold themselves together for long. As the universe expanded, it cooled, like a kettle left on the table after boiling. The fog gradually thinned, and for the first time particles began to join into stable atoms. This moment, when the universe gently shifted from a glowing cloud into something transparent, is an early sign that the conditions of reality do not remain fixed. Temperature changed, density changed, the cosmic environment drifted from one stage to another. And while this does not mean the rules themselves changed, it raises the question of whether some deeper parameters might shift just as gradually. Some theories suggest that certain physical constants, the quiet numerical values built into the universe, might drift over immense time. These constants include quantities like the strength of gravity or the behavior of the electromagnetic force. If these values shifted even slightly, the universe would respond in subtle ways. Stars might burn a little hotter or a little colder. Atoms might hold together with slightly different strengths. The way molecules form might change, but these shifts would be so slow that no single lifetime or even 1,000 lifetimes would notice them. Only the universe, stretching through billions upon billions of years, would detect the difference. Imagine, for example, that the strength of electromagnetic attraction drifted gently over time. At first, the change would be too small to matter. Light would continue shining. Atoms would behave the same. Chemistry would unfold with no noticeable difference. But over cosmic epochs, the binding of atoms might become slightly stronger or slightly weaker. Stars forming in the distant future might ignite at different temperatures. Their lifetimes might grow a bit longer or shorter. Galaxies might produce stars with subtly different patterns. The universe would not collapse or unravel. It would simply shift its rhythm, as though humming a familiar song in a slightly altered key. Another possibility involves the strength of gravity. If gravity were to drift slowly, either strengthening or weakening by tiny fractions, its effect would ripple outward across enormous expanses of time. A slightly stronger gravity would draw matter together more efficiently, leading to denser galaxies and more frequent starbursts. A slightly weaker gravity might encourage the cosmos to expand more freely, reducing the clustering of galaxies and making star formation rarer. In both cases, the universe would evolve differently, yet still follow deep, dependable rules. What makes these ideas especially calming is that their speculation remains gentle and grounded. No one imagines the laws of nature changing abruptly or chaotically. Instead, the thought is more like wondering whether the universe's constants breathe in and out over intervals so vast that entire galaxies rise and fade without noticing the shift. It is like contemplating whether the universe has a long, slow heartbeat, too soft to hear, too slow to measure in ordinary ways but present nonetheless. If the rules do drift, even by the smallest amount, then the history of the universe becomes a kind of story with chapters shaped by those shifts. The earliest stars may have formed under slightly different conditions than the stars shining today. Their light may have followed subtly different pathways. Their lifespans, colours, and inner reactions may have been influenced by a universe still settling into itself. Early galaxies might have spiraled differently. the formation of elements inside stars might have unfolded with slightly altered efficiencies. These possibilities give the cosmos a sense of growth, not a chaotic transformation, but a gentle maturation, like a tree adjusting its branches over the course of many seasons. At the same time, even if the rules shift, they would likely do so within constraints. The idea is not that the universe abandons its consistency, but that it might gradually refine it. Change, if it exists, would be governed by deeper rules, meta rules that shape how constants can drift. The universe would still be predictable, still stable, still trustworthy. Its evolution would follow patterns just as faithfully as its current behavior does. Even change would have its own gentle structure. The imagery of such an evolving cosmos feels less like a disruption and more like a quiet unfolding. Picture a distant galaxy, billions of light years away, drifting through space under gravity's subtle pull. The stars within it burn, shine, and gradually fade. If the rules shift slowly, then the stars forming in that distant galaxy's future might look a little different from the ones it produces now, yet the galaxy would remain recognizably itself. Its spirals would still curl gracefully. Its core would still glow warmly. The change would be no more dramatic than the soft aging of a living thing. In a universe where rules drift gently, chemistry might evolve in subtle ways too. The first molecules to form in the early cosmos were simple: hydrogen, helium, and small combinations of these elements. Over time, more complex chemistry emerged inside stars and on planets. If the constants guiding chemical bonds shifted slowly, the richness of molecular life could change in quiet increments. The molecules that form clouds, oceans, or living cells might differ slightly in the distant future. New combinations might become easier to form, while others might fade. It would be a gradual rebalancing, like the slow evolution of language across centuries. Still, all of this remains speculative, and the tone of such speculation is best kept gentle. These ideas do not assert that rules definitely change. They simply explore the possibility that nature's constants may not be eternally fixed, but instead might drift like shadows in the turning of a long cosmic day. Whether they do or do not, the universe remains understandable, because the deeper structure guiding its behavior remains consistent. There are also serenity in knowing that the universe does not rely on perfect stillness to be stable. Even if some constants change, the changes would be so gradual that the cosmos would adjust without difficulty, stars would continue shining, planets would continue orbiting, life, if it arises in distant futures, would adapt to whatever new conditions exist. The universe has room for evolution, and evolution does not erase order. In the end, the question of whether the rules change over time invites a kind of quiet reflection. It encourages you to imagine the universe not as a static blueprint, but as something with a long, graceful history. It has a past shaped by early fire, a present filled with shimmering galaxies, and a future that may continue unfolding in ways too slow for any one generation to witness. And whether the constants drift or remain perfectly steady, the deepest wonder remains the same. The universe behaves with a consistency that allows it to exist, evolve, and reveal itself in soft and beautiful ways across the vast sweep of cosmic time. Life often feels like something delicate, almost miraculous, as though it depends on conditions so precise that the slightest change could cause everything to unravel. Yet beneath its apparent fragility lies a remarkable harmony. Life exists because countless balances in nature hold steady, creating a calm pocket within the vastness of the cosmos. where molecules can organize, cells can cooperate, and organisms can breathe, grow, and wander. When you look closely, it becomes clear that life is not separate from the rules of the universe. It is shaped by them. It is supported by them. It is in many ways the expression of those rules woven into a form that can sense, respond, and flourish. To understand this, it helps to begin with temperature, one of the simplest but most important balances. Life depends on a narrow band of warmth. Not too hot, not too cold, too much heat, and the delicate structures inside cells would lose their shape. Too much cold and the machinery of life would slow to a stop. Water, in particular, plays a central role. It remains liquid across a comfortable range of temperatures, allowing molecules to drift and interact without freezing into stillness or evaporating into nothingness. This stability arises from the way water molecules bind to one another, forming a network that remains flexible yet cohesive. It is a quiet balance that gives oceans their softness, rivers their flow, and living cells their gentle fluidity. Chemistry offers another layer of harmony. Atoms join together in well-behaved patterns, forming molecules that can split, reassemble, fold and unfold in predictable ways. Life depends on these patterns remaining steady. The bonds that hold proteins together must be strong enough to maintain structure, but weak enough to allow change. DNA must be stable enough to preserve information, yet flexible enough to replicate. Each of these processes relies on the same underlying physical rules that govern the behavior of all matter. If the forces binding atoms were just a little stronger or weaker, the beautiful dance of molecular life would not unfold in the same way. These balances are not imposed. They arise naturally from the structure of the universe. Think about breathing, one of the quietest and most familiar rhythms of life. With each inhale, oxygen enters your lungs. That oxygen binds to iron atoms in your blood, carried by proteins shaped with astonishing precision. The shape of those proteins allows them to hold oxygen when levels are high and release it when levels drop. A perfect balance that delivers life to every corner of your body. This system works only because the molecules involved behave predictably. The way oxygen binds, the way proteins fold, the way cells respond, each step relies on stable patterns in the physical world. Even the simple act of breathing requires a delicate interplay of pressure and structure. Air flows from areas of higher pressure to lower pressure, moving effortlessly into your lungs when your diaphragm expands. This unassuming process is guided by the same rules that govern winds over mountains, currents in the ocean, and the drift of gases in distant nebulae. The consistency of these rules ensures that every breath follows the same quiet arc, sustaining life through a balance so smooth it can almost be forgotten. Water flow provides another gentle example of harmony. Water moves through soil, gathering minerals that plants need to grow. It flows through rivers, shaping landscapes in slow, patient strokes. Inside the body, water carries nutrients, removes waste, and cushions delicate tissues. All of these processes depend on the molecular structure of water and the forces that guide its attraction and movement. If water behaved differently, if it froze from the bottom up instead of the top down, if it did not expand when solidifying, if it did not dissolve a wide variety of substances, life would struggle to find a foothold. Water's behavior is not random. It is the result of simple rules repeated consistently, allowing life to weave itself through environments with elegant ease. The organization of cells offers another view of this harmony. Each cell is like a tiny world, filled with structures that perform specific tasks. Some parts build proteins, others harvest energy, others store information or repair damage. This organization relies on stable behavior at every level. Membranes form because molecules arrange themselves in the simplest way possible, with one side loving water and the other side avoiding it. Energy flows through cells because chemical reactions unfold in predictable sequences. Even the tiny engines that power movement inside cells work because their components behave consistently, stepping through processes that have remained unchanged for millions upon millions of years. These balances are deeply connected to the physical stability of the universe. The temperature of a planet depends on its distance from its star, the thickness of its atmosphere, and the way energy arrives and leaves chemistry depends on the balance between electric attraction and repulsion set by forces that never waver. Molecular organization depends on the shapes atoms prefer, the energy they share, and the ways they join and separate. Biological rhythms depend on cycles that trace back to the orbital motion of celestial bodies and the steady rotation of a planet under a constant sky. Life is woven into the universe with threads that connect the very small to the very large. There is something calming in realizing how these layers depend on one another. The rules that shape stars also shape the elements those stars create. The elements combine according to consistent tendencies, forming molecules with reliable patterns. Those molecules arrange themselves into structures that behave predictably, creating cells that can survive, adapt, and replicate. And from those cells emerge organisms, moving, thinking, breathing forms that reflect the same physical harmony that shaped galaxies and oceans. Life is not an exception to the universe's behavior, it is a continuation of it. This deep connection gives the universe a sense of unity, the balance that keeps a planet at the right temperature for water to remain liquid is part of the same balance that lets sunlight warm the ground. Plants grow in response, and animals breathe the oxygen those plants release. The rules that guide the flow of blood through arteries echo the rules that guide rivers across a landscape. The structures that allow cells to divide follow the same patterns that guide crystals to grow and frost to bloom on a window pane. Life fits gently into the same framework that shapes everything else. Understanding this connection can leave you feeling quietly anchored. You inhale, and that breath is supported by chemistry that has been reliable since the earliest days of the universe. You drink a glass of water, and its behavior is shaped by forces that also guide the formation of stars. You look at your hand or your reflection in a window, and the cells that form your body follow rules that have governed matter since the beginning of time. Far from making life feel small, this connection gives it depth. It reveals that being alive means participating in the same cosmic patterns that shape the sky. Life's reliance on these balances does not diminish its uniqueness. Instead, it highlights how extraordinary it is that the universe provides a home where such delicate processes can take place. The stability that allows stars to shine for billions of years also provides the steady energy life needs. The consistency that shapes atoms into molecules also shapes those molecules into living structures. The reliability of gravity, temperature, and motion gives organisms the space to grow, adapt, and flourish. By seeing life as part of this broader pattern, you may feel a quiet sense of belonging. You're not separate from the universe. You're made of the same elements that drifted through ancient stars, following the same rules that guide the tides and the turning of galaxies. Your breath, your heartbeat, your thoughts, all of them arise from the harmony of physical laws acting together with gentle precision. To be alive is to be a participant in the order of the cosmos, a small but meaningful expression of rules that create not just structure, but beauty and possibility. And as you let that thought settle, you may feel personally connected to the deeper order of the universe. The rules that allow life to exist are the same rules that shaped everything that came before you and everything that will come after. They do not simply support life, they resonate through it, reminding you that your place in the world is not accidental. It is part of a gentle, unfolding harmony that stretches from the smallest molecule to the farthest star. Understanders begins with noticing. A falling leaf drifts in a gentle arc. A sunrise brightens the horizon with steady calm. A stone dropped into a pond creates ripples that spread outward in widening circles. These small, predictable moments form the foundation of everything humans have ever learned about the world. The universe behaves in ways that are consistent enough for minds to study, explore, and eventually understand. Without that consistency, there would be no science, no knowledge, and no sense of familiarity in daily life. It is the quiet reliability of nature that allows meaning to form. Imagine trying to learn a melody on an instrument that changed its notes every time you touched it. No amount of practice or patience would help. The sounds would shift too often to form anything recognizable, but when the notes remain steady, the melody becomes something you can learn, repeat, refine, and finally understand. Nature offers this same steadiness. Its rules do not change from one moment to the next, and because of that, patterns emerge that the mind can recognize. The falling leaf follows a familiar curve because gravity responds with unwavering softness. The stone creates ripples because water behaves with predictable fluidity. Even the rising sun follows a rhythm set by the turning of a planet that never forgets its motion. This constancy gives the universe a knowable character. It allows the human mind, an organ shaped by the world it observes, to detect patterns, form memories, and make predictions. The mind evolved not in chaos, but in a place where light behaves reliably, where seasons return, where objects move according to simple tendencies. Over generations, these repeated experiences shaped brains that are sensitive to rhythm and structure. The ability to recognize patterns became a form of survival, woven into the very architecture of thought. You can sense when rain is approaching by the feel of the air, or when a path bends by the arrangement of trees. Each of these small perceptions depends on a world that behaves consistently enough to teach them. Understanding flourishes when the world repeats itself. Think of learning to read. At first, letters appear as strange marks on a page, but because each letter remains the same every time you encounter it, you begin to recognize shapes. Those shapes become sounds, and those sounds become meaning. If letters change their form at random, reading would be impossible. Nature works in this same way. Its behaviors, like letters, remain steady enough that the mind can piece together their patterns. Light bends in the same way each time it enters water, creating refraction that the eye can learn to expect. Shadows fall consistently with the position of the sun, teaching cycles through observation alone. Even the sensation of warmth follows patterns that allow you to anticipate change, like the cooling of evening air or the heat of a sunlit surface. Science is nothing more than the organized expression of this pattern recognition. People observe, compare, test, and refine their ideas, based on the dependability of the natural world. Experiments succeed only because conditions can be repeated. If a warm object cooled differently every time you measured it, the concept of temperature would dissolve into confusion. If objects sometimes floated upward for no reason, the idea of gravity would never have been discovered. Scientific knowledge rests on the assumption that the universe behaves today as it did yesterday and will continue to do so tomorrow. It is an assumption supported by centuries of experience, each moment reinforcing the reliability of nature. The human mind, shaped by these stable environments, naturally seeks rhythm. That is why cycles feel intuitive. Day and night form a gentle pulse. The seasons drift in and out with patient regularity. Tides rise and fall in a rhythm shaped by the pull of the moon. These cycles invite understanding because they repeat. They offer the brain something to hold on to, like a familiar song that returns to its chorus again and again. Without repetition, the world would feel ungraspable. With it, the mind finds comfort and clarity. Consider how a child learns about the world. They stack blocks, drop them, watch them fall, and try again. Each repetition teaches something quietly profound. Objects fall downward, not sideways or upward. Blocks stay solid. Surfaces remain still unless pushed. These simple observations form the foundation of intuition. Over time, they grow into deeper understanding. Adults may rarely think about these rules consciously, yet they rely on them constantly. Walking, reaching for objects, pouring water, lighting a candle. All of these actions depend on a universe whose rules remain faithful. The beauty of this consistency is that it allows understanding to accumulate. Knowledge layers gently over time, each generation building upon the insights of the ones before it. Because the universe behaves in stable ways, the discoveries of long-ago thinkers still hold true. The same mathematics used to describe planetary motion centuries ago continues to describe the movement of satellites today. The same principles that explain how heat moves through metal help guide the design of stoves, engines, and power plants. The rules do not erode with age, they remain reliable companions in every exploration. In this way, understanding becomes a shared experience across time. When you learn that water boils at a certain temperature, you're connecting with an insight recognized by countless others. When you look at the stars and feel that they move across the sky, you are witnessing the same rhythm observed by people long before modern science existed. And when you breathe, walk, or simply exist, you're participating in patterns that have guided the world since its earliest days. This connection between mind and nature brings a gentle warmth. Understanding does not require force. It arises naturally from noticing the world's behavior and trusting its steadiness. Even the most complex discoveries begin with simple observations: a falling apple, a drifting cloud, the flicker of a candle flame. Each moment of recognition begins with the same fundamental truth: nature behaves reliably enough to be understood. This reliability does not make the universe boring. On the contrary, it creates space for wonder. Because the rules are steady, new patterns can emerge. Because cycles are dependable, surprises can stand out brightly. Understanding brings depth, revealing that the world is not just predictable, but layered with meaning. Every sunrise is both familiar and quietly astonishing. Every breath is both ordinary and deeply connected to the structure of life. When you think of understanding as a product of rules, the universe becomes a kind of calm teacher. It repeats its lessons countless times: waves washing ashore, leaves turning in the wind, stars drifting through the sky. each repetition offering a chance to notice something new. The steadiness of nature does not limit understanding, it invites it. It encourages the mind to wander into curiosity, to follow gentle patterns, to explore rhythms both simple and profound. And as you let that thought settle, you may feel the same quiet reassurance that has guided countless thinkers before you. The universe is knowable not because humans are clever, but because nature is generous in its consistency. Understanding is simply the mind's way of recognizing the calm, repeating patterns that shape existence itself. A universe built entirely from randomness would never form anything with shape. Particles would not follow paths, forces would not act reliably, atoms would not remain intact from one moment to the next. Nothing would persist long enough to become a star, a planet, a molecule, or a living cell. Without rules, reality would dissolve into flickering chaos with no structure to hold it together. The presence of rules allows the universe to exist in any stable, meaningful form. They give matter the chance to gather, organize, and endure. One way to think about this is to imagine that certain behaviors are simply the only ones that can support a coherent universe. If energy could appear or vanish unpredictably, interactions would collapse. If motion depended on sudden whims, stability could not form. Some patterns may be required for the universe to remain whole. Such rules might arise not from choice, but from necessity, allowing existence to maintain consistency instead of tearing itself apart. Symmetry offers another lens. Many of nature's rules emerge because the universe behaves the same in different directions and at different times. Gravity pulls no matter which way you face. Light travels the same way whether it moves upward or downward. Time flows with even rhythm from moment to moment. These symmetries create balance, and from that balance come the laws that shape matter and energy. If the universe had no symmetry, forces might act unevenly, directions might behave differently, and no stable patterns could emerge. There is also the possibility that among many imaginable universes, only those with reliable rules continue long enough to form structure. A universe with no stability may collapse immediately, or dissolve into disorder before it can develop stars, elements, or chemistry. Only those with stable laws would have the capacity to grow, form patterns, and maintain themselves. Rules may exist because universes without them cannot persist. Some patterns might emerge because simple interactions naturally settle into organized behavior. When air cools, frost grows in branching shapes without guidance. When sand shifts, it forms ripples under the wind. When droplets gather, they form spheres. In each case, order forms because the simplest outcomes become the most stable. Rules might arise because interacting components naturally drift toward consistent behavior. Even without intention, the simplest patterns may be the ones that last. Another thought is that the rules we observe could be shaped by deeper structures we do not yet understand. If the laws of nature are themselves the results of more fundamental principles, then the universe might follow these patterns because they are part of a larger framework. The rules may not be arbitrary. They may be expressions of something deeper that has not yet been uncovered. Yet even with these possibilities, the question remains open. Why these specific rules? Why this particular balance of forces? Gravity could have been slightly stronger or weaker. Atomic attraction could have been tuned differently. Light could have behaved in alternative ways. Any small change might have produced a universe unable to form stars, matter, or life. The values that exist now allow atoms to bind, stars to shine, and planets to orbit peacefully. These balances create a cosmos where complexity can arise and endure. Rules give the universe the ability to change without collapsing. They allow atoms to form and stay together. They allow energy to move in predictable ways. They allow chemistry to build structures, and those structures to support life. Without dependable rules, nothing could take shape or continue for more than a moment. With rules, the universe becomes a place where stars ignite, elements spread, and life finds space to grow. The question of why order exists instead of total randomness does not resolve neatly. It remains an openness gentle mystery. Rules might arise from logic, symmetry, necessity, or deeper structures. They may simply be the conditions under which a universe can hold itself together. What they unquestionably provide is the foundation that allows matter, energy, structure, and life to appear in a world that remains steady enough to understand and calm enough to endure. There is something quietly intriguing about the thought that the rules guiding the universe might not be the deepest layer after all. Beneath gravity, beneath electromagnetism, beneath the behavior of light and matter, there may be gentler principles shaping everything from behind the scenes. These deeper patterns, sometimes called meta-rules, would not tell particles how to move or how forces must act. Instead, they would form the overarching scaffolding that all known laws rest upon, the framework that makes laws possible in the first place. One way to picture a meta-rule is to imagine the architecture of a building. You can walk through the rooms, admire the walls, and notice how they connect. But every room depends on beams and supports hidden behind the surfaces. Those unseen structures do not dictate the details of each room, they simply make the rooms possible. In a similar way, meta-rules may shape the conditions under which the familiar laws of nature can exist, holding the cosmos together quietly from beneath its visible surface. A gentle starting point for this idea is symmetry. Symmetry is not just a pattern that objects have, it is a principle that influences how the universe behaves. When nature treats all directions equally, forces like gravity become smooth and even. When it treats all moments consistently, the unfolding of time becomes regular. These symmetries shape many of the laws we experience, yet the symmetries themselves feel deeper than the laws built upon them. They do not tell objects what to do. They provide the background conditions that allow objects to behave in stable, predictable ways. Another candidate for a meta-rule is consistency. The idea that the universe behaves the same from one moment to the next is so familiar that it is easy to overlook. Yet this consistency might be one of the most fundamental principles in existence. If the universe were inconsistent, if its behavior shifted abruptly from one moment to another, no law could hold and no structure could survive. Consistency does not dictate the details of how matter and energy interact. It simply allows interactions to remain steady enough for rules to form. It acts like a calm foundation beneath the constant motion of the world. Information offers another way to think about meta-rules. In many modern ideas about physics, the universe can be viewed as an immense flow of information. The arrangement of particles, the behavior of forces, the structure of space and time. These may all be expressions of information being stored, changed, and transmitted. If this is true, then information itself may follow deeper principles that shape how it can behave. These principles would sit beneath the familiar rules, guiding the very possibilities available to the universe. The cosmos would become a vast, shimmering tapestry of information, threads woven together in ways that are both orderly and free. These possibilities invite a different way of imagining reality. Instead of seeing the universe as a collection of isolated laws stacked beside each other, you can picture it as a structure built from a small number of guiding themes. Symmetry keeps the world balanced. Consistency keeps it continuous. Information gives it the ability to express patterns. These meta-rules may work together like the subtle currents beneath an ocean surface, steadying the waves while allowing them to move freely. A calm metaphor for this is the behavior of music. A melody can take countless shapes, drifting upward or downward, slowing or rising, softening or growing bold. Yet behind every melody lies a simple foundation. Notes must follow consistent relationships. Without that underlying framework, music would collapse into noise. The rules of melody arise not because they are imposed, but because the deeper structure of musical harmony allows them. In the same way, the laws of physics may arise because meta-rules give them space to exist. The universe's melody is possible because its deeper architecture holds steady. Another soothing way to imagine meta-rules is to picture floating through a vast invisible lattice that supports everything you see. Stars drift within it, light travels along it, atoms move through it. The lattice itself is not made of matter, it is made of tendencies, gentle guiding principles that shape what is possible. Gravity may be one expression of this lattice, electromagnetism may be another, but the lattice beneath them would remain even if the specific expressions changed. It forms the quiet groundwork of reality. One of the most elegant ideas in modern physics suggests that many familiar laws can be derived from deeper principles that demand the universe behave in certain self-consistent ways. For example, if a system must conserve energy, certain symmetries must exist. If information must be preserved, certain processes become impossible. These deeper principles shape the space of possible laws long before any specific law takes form. They are not detailed instructions. They are the conditions that shape which instructions can ever exist. This view can make the universe feel surprisingly unified. Instead of imagining dozens of separate laws acting independently, you can think of reality as an interconnected web supported by only a handful of quiet meta-rules. Everything else flows naturally from these foundations. The behaviors of atoms, the paths of planets, the glow of stars, the shape of galaxies, all of them unfold from deeper patterns that remain steady beneath every event. Even time and space may follow meta-rules. The smoothness of space, the continuity of time, and the ability of matter to move through both may be products of principles that sit deeper than geometry or motion. These hidden rules give the universe its stage and determine what sorts of stories can unfold upon it. Without them, even simple continuity would vanish. Thinking in this way shifts the perspective gently. Instead of seeing laws as fixed commandments, you can view them as possibilities encouraged by deeper patterns. The universe does not need to enforce laws. It simply behaves according to the structure allowed by its meta-rules. These principles limit chaos, encourage order, and provide space for complexity to grow. This softly reveals that the universe may be less a machine built from rigid instructions and more an unfolding pattern shaped by a few guiding rhythms. Symmetry, consistency, and information act like supports, allowing the rest of reality to blossom. The laws we recognize, from the behavior of gravity to the structure of atoms, become natural consequences of these deeper rhythms rather than isolated rules. As you drift through these thoughts, it becomes possible to imagine the universe as an immense architecture built from invisible supports. Galaxies flow through it like lanterns carried on a slow current. Particles move within it like dust motes gliding in a sunbeam, and the laws that govern everything do not float independently. They are suspended from the same quiet scaffolding that stretches across all of existence. Whether these meta-rules are truly the deepest layer, or whether there is an even further foundation waiting quietly underneath, remains unknown. Yet the possibility alone brings a sense of coherence. It suggests that beneath the movement of every particle and the glow of every star lies a small set of gentle principles guiding the cosmos from its roots. Randomness often feels like the opposite of order, as though it stands outside the boundaries of rules. A raindrop landing on a window seems unpredictable. A flickering star appears to shimmer without pattern. The temperature of a breeze shifts with no warning. Yet beneath these scattered moments there is a quieter truth. Randomness does not mean chaos, and it does not mean the absence of structure. Even the most unpredictable events follow gentle statistical tendencies that guide their behavior. In this way, randomness becomes another expression of the universe's order, a softer, looser kind of rule that reveals itself not in individual moments, but in the patterns that emerge over time. One of the clearest examples is rainfall. No one can say exactly where a particular raindrop will fall or when the first drop of a storm will appear. The path of each droplet is influenced by countless tiny factors in the air, gusts, temperature gradients, microscopic dust, making precise prediction impossible. Yet when you step back and look at the bigger picture, rainfall follows steady patterns. Over a year, a region receives an average amount of rain that remains surprisingly stable. Wet seasons and dry seasons return with familiar rhythm. Storms distribute their droplets in ways that follow predictable shapes. The unpredictability of any single raindrop is part of a larger pattern that remains remarkably consistent. This combination of unpredictability and stability is one of the hallmarks of statistical order. Individual events may behave freely, but when many events occur, their collective behavior settles into a calm and dependable rhythm. The mind can sense this even in everyday experiences. When you look at a cloudy sky, you cannot track every swirling shape, yet you can recognize the overall mood of the weather. It has a character you have learned to predict, even without precise details. The same principle applies in many places throughout nature. Starlight flicker is another example. When you gaze up at a star on a clear night, its brightness twinkles delicately. The flicker feels like pure randomness, and in a way, it is. The atmosphere is filled with layers of air that constantly shift, bending and scattering the light from stars. These movements are small and unpredictable, making each moment of shimmer unique. Yet if the flicker were recorded and analysed over time, patterns would appear. The brightness fluctuates within a certain range, never plunging to complete darkness or rising far above its average glow. The twinkling is random, but only within boundaries. It behaves like a quiet pulse shaped by probability. Temperature fluctuations follow this same gentle pattern. The movement of air molecules is wildly unpredictable. Each one zips around in a different direction, bouncing and drifting with no central guidance. Yet the combined behavior of trillions of these molecules creates something smooth and stable. When you feel a warm breeze, you are sensing the average energy of countless particles. Their individual randomness merges into a consistent temperature that can be measured, predicted, and described. The universe uses randomness to create patterns that are both flexible and steady. Probability forms the backbone of these patterns. It's a way of describing how often certain outcomes occur when many events unfold together. A coin flip, for example, is unpredictable in the moment. Yet the more often you flip the coin, the more closely the results follow a steady distribution. Rainfall behaves in the same way. The path of any single droplet cannot be predicted, but the overall pattern of many droplets can. Even the flicker of a star obeys statistical rules, wavering within ranges defined by the conditions of the atmosphere. Probability becomes the rule that guides randomness, giving it structure without eliminating its freedom. This becomes especially clear when looking at natural patterns that are formed from large numbers of small random events. Consider the distribution of pebbles on a beach wave stir and scatter the stones unpredictably. Yet over time, the beach settles into familiar gradients. Larger stones gather near the waterline, smaller grains drift away, and patterns form without any plan or intention. Each wave behaves differently, but the accumulated effect creates order. Probability guides how often stones of various sizes are moved or settled, producing a beachscape that feels both natural and coherent. Snowflakes provide another glimpse into the marriage of randomness and rule. Each snowflake begins as a tiny crystal forming in a cloud. The precise shape it develops depends on the temperature, humidity, and movement of air around it, conditions that shift constantly and unpredictably. Yet every snowflake follows the same basic rule. It grows in sixfold symmetry, forming patterns that echo a common geometric backbone. The randomness shapes the details, but the rule shapes the overall structure. Each flake is unique, yet all share a family resemblance rooted in fundamental behavior. Randomness also guides the behavior of gases, forming a discipline known as statistical mechanics. In a room filled with air, each molecule moves unpredictably, yet the pressure of the air remains steady. The temperature stays within a narrow range. The gas fills every corner evenly. These properties arise from the lawfulness of probability. The randomness of individual molecules merges into order when viewed collectively. It is a reminder that unpredictability on small scales can be the foundation of stability on larger ones. This interplay between randomness and order is present even in the patterns of life. Heartbeats, for example, are not perfectly regular. They vary slightly from moment to moment, creating a subtle randomness in their rhythm. Yet this variation is guided by biological processes that keep the heartbeat within healthy bounds. Too much randomness becomes dangerous, but too little can be a sign of stress. The heart relies on a balanced blend of structure and variation. It is a living example of how randomness can support, rather than disrupt, natural systems. Another example appears in the way leaves fall from trees. Each leaf drifts on a unique path, turning and spinning unpredictably as air currents push and pull it. Yet the overall shedding of leaves follows a seasonal cycle that returns year after year. Probability shapes how many leaves fall each day and how they scatter across the ground. Randomness fills the details, but the broader behavior remains steady. This gentle combination allows forest floors to develop textures that feel both organic and harmonious. When randomness and order work together, they create patterns that feel alive. Pure order can become rigid, leaving no room for variation. Pure randomness becomes noise, losing the ability to form patterns. The universe we inhabit sits between these extremes, blending predictable tendencies with unpredictable details. This balance allows storms to form, winds to wander, landscapes to change, and life to adapt. It gives the world texture and richness, preventing it from becoming overly strict or entirely chaotic. Probability itself behaves like a law. It does not dictate exactly what must happen. but it guides what is likely to happen. This guidance gives randomness a kind of softness. Each event can follow its own path, but the overall story remains stable. In this way, randomness becomes another language the universe uses to write its patterns. It creates variety without destroying structure. It allows complexity to arise, because systems can explore many possibilities while still remaining anchored by deeper tendencies. Thinking of randomness in this way reshapes the idea of what a rule is. A rule does not always need to tell every particle where to go. Sometimes a rule simply describes how outcomes gather around certain averages. Sometimes it describes how countless small uncertainties blend into larger certainties. Sometimes it describes the range of possibilities rather than a single fixed result. These softer rules give the universe flexibility, letting structures form even when individual components behave freely. Seen from this perspective, randomness becomes part of the universe's order, not an exception to it. It is woven into rainfall, starlight, breezes, and living rhythms. It shapes the world without overwriting the stability beneath it. The universe does not choose between order and randomness. It uses both, combining them in ways that create depth, richness, and endless variation. Reality behaves as though it values harmony above everything else. Every law that shapes the world fits together with every other law without contradiction, forming a seamless structure where events unfold reliably and consequences follow causes with quiet precision. This self-consistency is so deeply woven into existence that it becomes easy to overlook. Yet without it, nothing familiar could endure. Matter could not settle. Light could not travel smoothly. Chemical reactions could not unfold in dependable ways. Even the idea of time passing would lose meaning. Consistency is what allows the universe to be a place where stability, motion, and life can exist without collapsing into confusion. Imagine trying to live in a world where contradictory rules operated side by side. In such a place, objects might fall downward one moment and drift upward the next without reason. Light might travel quickly in one direction and slowly in another. Atoms might bind tightly today but fall apart tomorrow. Cause and effect would blur, predictions would fail, structures would crumble as soon as they formed. Even the most basic rhythms, like the rising of the sun or the beating of a heart, would lose their coherence. In a world governed by contradiction, nothing could last. The universe would be a constantly shifting haze without patterns, forms, or memory. Instead, the universe behaves with remarkable agreement. The laws that guide motion align with the laws that guide force. The principles that shape energy align with the principles that shape matter. Everything fits together with gentle logic. This harmony allows cause and effect to operate smoothly, turning the unfolding of events into a quiet chain rather than a storm of unpredictability. When something happens, the next moment follows naturally. A wave breaks because of the wind that pushed it. A leaf falls because gravity draws it downward. A star shines because the reactions within it proceed with unwavering reliability. Each event supports the next, like steps in a path that never abruptly shifts direction. Planetary motion offers one of the clearest examples of this consistency. The planets circle the sun in paths that remain stable over immense spans of time. Their orbits follow predictable curves because gravity acts in the same way everywhere along their journeys. There are no hidden contradictions waiting to disrupt their motion. The planets do not wobble into chaos because nothing in the universe behaves in a way that conflicts with the forces guiding them. Their motion becomes a calm expression of harmony, an example of how consistency creates beauty on the scale of entire worlds. Chemical reactions display a similar coherence. When two substances interact, they combine and transform in ways that follow stable patterns. Water always breaks into hydrogen and oxygen under certain conditions. Salt always forms crystals in familiar shapes, because the atoms arrange themselves in ways that minimize energy. These outcomes depend not on chance, but on the consistent behavior of molecules. The same interactions repeat reliably across oceans, clouds, rivers, and living cells. Chemistry works only because the deeper rules of matter do not contradict one another. They support each other like interlocking threads in a tapestry. Sound waves offer another gentle illustration. When a sound is created, whether by a voice, a breeze, or a musical instrument, it moves through air as a wave of pressure. These waves spread smoothly because the air behaves consistently. Each molecule passes its motion onward to the next, creating a ripple that travels with steady behavior. If the laws guiding pressure and motion contradicted one another, sound would not form coherent waves. It would break apart into fragments or vanish as soon as it formed. Instead, sound moves in a way that feels familiar, even comforting. Its stability is a direct result of the deeper self-consistency of the universe. This harmony appears not just in isolated examples, but in the connections between all layers of reality. The rules governing the smallest particles do not conflict with the rules that shape stars and galaxies. Light behaves consistently whether it passes through a microscope or across interstellar space. Gravity acts gently on a falling leaf and powerfully on a distant planet, yet it follows the same fundamental principle in both cases. This unity allows everything to exist within a single coherent framework. The universe behaves like a vast poem in which every line supports the meaning of the others. The self-consistency of reality also makes understanding possible. If the universe behaved with contradictions, the mind could not learn how anything works. Patterns would fail as soon as they appeared. Observations would be unreliable. Predictions would collapse. Instead, nature repeats its behaviors faithfully, allowing the mind to recognize rhythms and build knowledge with confidence. Learning becomes possible because the universe stays true to itself. There is something soothing in the thought that contradictions cannot persist in the physical world. If two rules disagree, the universe resolves the disagreement by making only one of them true. A single, unified set of principles prevails, shaping everything from the smallest particles to the largest cosmic structures. This unity prevents confusion at every scale. It ensures that a star shines the same way today as it did billions of years ago. It ensures that the water in a river flows with the same physical tendencies as the water in a cloud. It ensures that the forces acting on your hands, your breath, your heartbeat behave reliably enough to support life. This coherence extends into time itself. A cause leads to an effect. The effect becomes a new cause, shaping the next result. The chain does not break or reverse without reason. The universe honors the relationship between past, present, and future with steady respect. This respect creates a sense of continuity that stretches from the earliest moments of the cosmos to the quiet experiences of daily life. Every event fits into this continuity like a bead on a string. Thinking about this underlying harmony can make the universe feel less like a collection of separate pieces and more like a single, well-tuned whole. Every law, every pattern, every interaction aligns with all the others, the consistency becomes a kind of gentle foundation that holds everything steady. It allows stars to form, planets to orbit, atoms to assemble, and life to grow. It gives the world a sense of coherence that runs deeper than any one phenomenon. Even randomness fits comfortably within this structure because randomness itself obeys statistical rules. There are boundaries within which chance events occur. There are patterns beneath the unpredictability. Nothing escapes the deeper framework. Even the most erratic processes follow tendencies that reflect the consistency of the universe. This unity suggests a possibility that whispers quietly beneath many scientific and philosophical ideas. Perhaps consistency is not just one rule among many. Perhaps it is the deepest rule of all. A universe that cannot contradict itself becomes a universe that can exist, evolve, and reveal its patterns. Consistency may be the foundation upon which all other laws rest, the quiet principle that allows matter, energy, time, and space to behave with harmony rather than confusion. When you notice this consistency, whether in the steady arc of a planet, the repeatable behavior of chemicals, or the soft echo of a sound wave, you're witnessing the universe's underlying coherence. It is the quiet promise that reality will not suddenly shift into contradiction. It is the assurance that the patterns shaping the world are not fragile. They are deeply rooted in structure that remains whole. From the flow of a river to the glow of distant stars, everything unfolds within this self-consistent framework. It is the quiet architecture of existence, holding the universe together with gentle, dependable strength. The deeper you travel into the question of why reality follows rules, the more the universe begins to feel like a place shaped by quiet harmony. Every law, every pattern, every symmetry seems to rest on something deeper, something calm and self-consistent. And as you return from these depths toward the surface of everyday experience, the world around you begins to feel gently different, not unfamiliar, but clearer. The same sky, the same breath, the same soft movements of life. Yet now each moment carries the quiet echo of everything the universe does to hold itself together. The journey begins with the simple observation that nature behaves with remarkable steadiness. Objects fall, light travels, water flows, and patterns repeat not by command, but because the universe drifts naturally toward consistency. Even the smallest details of daily life, like the warmth of a cup in your hands or the rhythm of footsteps on the ground, exist because matter and energy behave in reliable ways. Beneath each of these familiar moments lies an intricate web of rules working in perfect synchrony. At the heart of that synchrony is pattern. The universe repeats itself often enough that the mind can recognize shapes, rhythms, and connections. Spirals appear in seashells and galaxies. Waves rise and fall in water, air, and even light. Branching structures form in trees, rivers, and lightning. These recurring forms emerge not from intention, but from simple interactions repeated over time. They reveal that the universe does not need complexity to create beauty, it only needs consistency. The repeated gestures of nature paint the world in shapes that feel both familiar and endlessly varied. Symmetry adds another layer of quiet order. Because the universe behaves the same in every direction and every place, patterns unfold evenly. A snowflake grows with balanced grace. A planet forms as a sphere. The stars drift along arcs defined by the smooth flow of gravity. These symmetries act like anchors, keeping the world steady. They are not rules in the usual sense. but gentle constraints that prevent chaos and allow structure to bloom. The harmony they create can be felt in something as small as a pebble, or as vast as the glowing arms of a spiral galaxy. Stability gives everything the chance to last long enough to take form. The conservation of energy, the reliable behavior of atoms, the predictable way matter gathers, all of these make it possible for stars to shine, planets to orbit, and life to evolve. The stability of physical laws allows the universe to store memory. Each moment builds upon the next without crumbling. This persistence enables growth in all its forms, from the shaping of mountains to the development of living minds. Beneath these layers lies something softer and more philosophical: logic. Not the logic of language or argument, but the quiet logic of existence itself. A universe with contradictions could not hold itself together. Contradictory laws could not produce stable structures. The coherence of reality suggests that consistency may be the deepest principle of all, the foundation upon which everything else rests. This self-consistency ensures that the universe does not tear itself apart, that patterns remain meaningful, and that cause flows gently into effect. Even randomness follows this logic. The unpredictable flicker of starlight and the scattered fall of rain droplets both obey statistical tendencies. Probability shapes uncertainty into patterns that feel alive but not lawless. The universe uses randomness not to break order but to enrich it. The details vary, the bigger picture holds steady. This blend of freedom and stability gives nature its texture, its gentle irregularities, its soft surprises, its living rhythm. And as all these threads weave together, patterns, symmetry, stability, logic, probability, they create a universe that feels less like a mechanism and more like an unfolding story. Each chapter follows naturally from the one before it, guided by rules that remain calm and dependable. Every law supports every other law. Every pattern is connected to countless others. The cosmos behaves like a single, coherent whole, even as it expands across unimaginable distances and scales. The most comforting part of this journey is realizing how closely everyday life reflects the same principles. The reliability that governs starlight also shapes the glow of a candle. The symmetry that guides galaxies also shapes the curl of a fern. The stability that allows atoms to bind also supports the beating of a heart. The probability that helps raindrops scatter also shapes the warmth of a breeze. The same rules that guide the universe guide your experience of it, moment by moment. This connection gives ordinary moments a quiet, almost sacred weight. Each breath becomes part of a pattern that stretches across the entire cosmos. Each step rests on rules that hold galaxies together. Each heartbeat echoes the same stability that allows stars to shine. Everything you see and feel and are is woven from the same fabric as the most distant places in the universe. And as you return to the central question, why reality follows rules, the answer becomes less about solving a mystery and more about appreciating the beauty of the world that those rules create. A universe without rules would be noise. A universe with rules becomes a place where light flows, matter gathers, and life can rise from the quiet organization of atoms. The rules do not limit the universe. They allow it to exist, to endure, and to become something magnificent. As you settle into the final moments of this reflection, the universe may feel a little calmer, a little more connected, a little more meaningful. The same rules that guide distant galaxies guide the ground beneath you. The same patterns that shape starlight shape your breath. The same consistency that holds the cosmos together holds each moment of your life with gentle steadiness. And in that realization lies the soft, sleep-friendly truth at the heart of everything. The universe follows rules because rules allow harmony, and it is within that harmony that beauty, structure, and life find their place.